the first, let's see, the session chair is it Chris here? No, no session chair. Right. Okay. So I think that thank you again for the comment. I think that I'm really happy that you are safely come to Japan and without trouble or with trouble. And I think it's the first at first, and I'd like to introduce my the director of my center, Earth Observation Research Center, Osamu Chai. Unfortunately, he cannot come to here in person, but he joined the meeting remotely, and then he will make the kind of welcome speech and here from now. And also then the Professor Ebuchi will make the welcome from Hokkaido University with logistic information. Okay, so Uche-san, so I will Uche-san, can you speak?
Yes. Can you hear me now?
Wait a moment. ちょっと音が小さいですね。はい。Can you speak speak louder?
Okay. How about this? Is it okay?
Sorry, I think that the setting in the room could be a little bit. Could you say again?
How about this? Can you hear
It's
me?
good. Yes.
Okay. Okay. All right. Hi, everyone. Good morning, ladies and gentlemen. Welcome to Japan. So I hope everyone had a pleasant trip. It is my great pleasure to co-host, together with Hokkaido University, the 27th International SST User Symposium and GHRSST Science Team meeting here in Sapporo. Hokkaido University is actually my alma mater, where I studied geophysics, and I'm very familiar with the Institute of Low Temperature Science. Therefore, it is great pity that I cannot be there in person today due to other commitments. So as you will see, the university offers a spacious campus and a wonderful environment. So I sincerely hope that you will have a fruitful discussion that inspire innovative ideas and contribute to advanced science. Now, please allow me to introduce the JHRSST solution activity through the following slides. Next slide, please. First of all, I apologize for presenting such a complex slide. However, it will illustrate a long history of Earth observation of satellite activity at JAXA. Since the 1990s, we have a continuous development of Earth observation satellites and instruments across several areas. These include a precipitation radar, greenhouse gas monitoring instruments, and microwave radiometers, multispectral imagers, radiometers, and synthetic aperture radars. As you can see, many of these systems are now in their second or maybe third generations, providing nearly 30 years of continuous data records. Through these efforts, we have advanced not only scientific research, but also the practical applications in areas such as water cycle monitoring, disaster and land observations, climate studies, and precipitation and greenhouse gas information for political stakeholders. In the past 2 years, we have successfully launched 3 new satellites, GOSAT-GW, EarthCare, and ELOS-4. These missions are expanded to further enhance both scientific understanding and operational application. Next slide, please. I would like to highlight how JAXA has contributed to international Earth observation initiatives. As an example, JAXA has a member of the Committee on Earth Observation Satellite, CEOS, for over 40 years since its beginning. CEOS brings together 34 space agencies and 32 associate members to coordinate and harmonize Earth observation activities. Its goal is to make data more accessible, usable for the global user community by promoting interoperability, common data formats, intercalibration of instruments, and consistent validation intercomparison of those products. JAXA has played a key role within CEOS, including leading several important biological constellations such as atmospheric composition, land surface imaging, precipitation, and sea surface temperature. Ms. Misako Kaji is currently co-leading the SST virtual constellation together with South Africa, and this activity is closely connected to the international SST and your communities. In addition, JHRSST served as chair of the CEO's strategic implementation team over the past 2 years. During this period, we led the development of the sales strategy to support the global stocktake, as well as associate carbon roadmaps in 3 domains to support the implement of the UNFCCC's Paris Agreement. Next slide, please. In recent years, the frequency and the intensity of the climate extremes have increased worldwide, as you know. In Japan, sea surface temperature have risen to unprecedented levels, particularly in northern regions. The left panel shows the monthly global means SST derived from AMSA-E and AMSA-2 observation from 2002 to 2026, highlighting the clear warming trend and the record high temperatures in recent years. The right panels presents the SST anomaly for May 2026, illustrating significant elevated temperature around Japan, as well as onset El Nino conditions since April. These results demonstrate the recent development of marine heat wave conditions and underscore the potential impact of the regional climate marine ecosystem around Japan. Next slide, please. I would like to emphasize how JAXA contributes to the essential climate variables, or ECVs. As you know, the Global Climate Observing System, GHRSST, has identified 55 ECVs across the atmosphere, land, and ocean domains. JAXA Earth observation missions are currently measuring 27 of these variables, and sea surface temperature is one of the most important variables for the climate monitoring. It is imperative not only to continuously monitor these changes, but also to improve our ability to predict future conditions over the coming years. As I mentioned earlier, our mission history is now approaching 30 years. Not only JAXA, but also many other space agencies have accumulated long-term data records. This places greater responsibility on space agency and CEOs to further strengthen their contributions to climate monitoring. Next slide. By leveraging more than 30 years data records and sustainable data pipeline, I believe we need to place greater emphasis on short-term climate forecasting. To achieve this, we have started collaborating with various modeling communities to integrate satellite data into their models. This will help enhance future predictions and further contribution to both science and society. This chart our vision, or maybe I should say ambition, to develop a comprehensive data twin platform. This platform would integrate and assimilate Earth observation data and models across multiple domains, providing predictive narrative-based outputs as a decision-ready information. Such a platform could support a wide range of applications, including a natural disaster management, fisheries, public health, agricultural ecosystem, and more. Next slide, please. This represents a more pragmatic approach towards achieve our ambition. JAXA has begun collaborating with modeling committee through initiative funded by Ministry of Science and Technology, MEXT, such as the CENTAM project, as well as the data integration analysis system we call the DIAS. Through this collaboration, we aim to deliver both short-term and long-term predictive analysis. The resulting information will be shared not only to the international community, including a framework such as IPCC or maybe CMIP, but also the local authorities. In this way, we hope to support both mitigation adaptation efforts, ultimately contribution to the enhanced climate resilience. Next slide, please. And finally, JAXA strongly supports sea surface temperature monitoring activities as an island nation surrounded by the ocean. Changes in SST have a direct impact on our daily lives. GHRSST is one of the long-standing scientific committees, and JAXA has honored to participate since its second meeting in Tokyo 2002. I understand that we have had the privilege of hosting this important event once every decade. By the way, coincidentally, we also hosted the 30th anniversary meeting of the International Ocean Color Coordination Group, IOCCG, in Tokyo last month. In this regard, I would like to once again express my sincere gratitude to all of you attending this important meeting, both on-site or maybe online. I sincerely hope that you will have highly fruitful and productive discussion. Thank you very much for attention.
Thank you, Chai-san, for the welcome speech. Okay, next, the Professor Ebuchi from Hokkaido University.
Okay, good morning, everybody. Thank you for joining us. I'm Naoto Ebuchi of the Low Temperature Institute of Low Temperature Science, Hokkaido University. And on behalf of the institute, I'd like to welcome all the participants on site and online. And it's a great honor for us to host this meeting. And I'm going to introduce very briefly in our university and institute, and I have a lot of housekeeping announcements. So, this is our campus. Our institute is located here, located in the north edge of the campus, and this is Sapporo Station. And this is the statistics of our university, and we have 12,000 undergraduate students and 6,000 graduate school students. And probably we have, say, how many? Wow, I cannot see it. About 2,000 faculties. And we have 12 undergraduate schools and 21 graduate schools. I don't have to introduce in details of this. And my institute is founded in 1941, before the World War II. And as a first research institute affiliated with the Hokkaido University. And at present, we have 41 faculties, 31 research staffs, and 10 administration staffs, and 9 technicians. And also, we have about 80 graduate school students. And our institute was initiated by the achievement of the Dr. Kichiro Nakata. He succeeded in making the artificial snow in laboratory in the first in the world. So you can see the very old facilities at the time, and the buildings, and So our institute is founded in 1941, and they focusing on the interdisciplinary research in the physics and biology and chemistry in cryosphere. And at present, we have 3 research divisions and research center. I belong to the water and material cycle divisions. So we have we did some approach for the physical oceanography, atomic chemistry, glaciology and hydrology, marine chemistry, and lots of approaches with the field experiments, remote sensing, and numerical modeling. And also we have a CI snow division, including space, astronomy, and the astrophysics, and also have some division in the biology. And also we have the research center of the Okhotsk Sea region, including CI studies. This is the very brief introduction. And I have some announcement or housekeeping announcement. Please do not bring any drinks. So please do not bring this cup in this room. The bottles are okay. So please enjoy your refreshments out also the coffee room or postal section, postal area. And for Wi-Fi, probably you already get the seat. So individual participants have your own ID and password. And please return to the lower part to the reception desk. We can count the number. And also, if you have 2 or more devices, you need the 2 or 3 IDs individually. You please do not mix up the use the same ID from the different devices. Probably the university staff can easily find it and then kill your ID soon. Yes? No. No. You need 2. And we prepare the 3 maps, the places for lunch and campus and the city. And also the JAXA people prepare some souvenirs of the pin badge and something like that. It's over there. In campus shuttle, we have a small bus running every 20 or 30 minutes. And if you, this is our institute, and this is the headquarters of the administration office of the university, and you can 5 minutes to the Sapporo station. But it's not very big bus. It cannot take all of us. So if you need, please let me know. And smoking is strictly prohibited in the campus, in the building and outside of the building. So please do not smoke. But we have only one exception. So if you need a facility, please let us know. Or you can smell it. And soda machine. We prepare the water and coffee and tea and something like that. But you need if you need a very cold drinks, the vending machine is located in the room 201 on the main building. And in case of emergency in Sapporo region, please call me. But I cannot help you in Haneda or in Tokyo or anywhere. And also, one more, brown bear. It's I'm serious. Yes. In the western part and southern part, the brown bears have been spotted, even in the city. So if you plan to go hiking or walking in early morning or other activities, other outdoor activities, we recommend checking the information before. Otherwise, I don't know. Okay, so we hope you enjoy the meeting and stay in Sapporo. That's all I have. If you have any questions.
Thank you. Good morning, everyone. My name is Chris Merchant, and I'm from the University of Reading in the UK, and it's my pleasure to thank Director Ochiai and Professor Ibuchi for their speeches and all the interesting and important information, including the brown bear warning, which we will take very seriously. It's great to be here in Japan, the third GHRSST meeting that's happened in Japan, although I've only managed to be at 2 because I was not in the second meeting. But this is my second GHRSST meeting in Japan. Very glad to be here and to see such a full room. And people have traveled a long way, maybe feeling a bit jet lagged like I do. But hopefully all the content we're going to hear today and in the course of the week will make us very attentive and alert. So thank you very much to JAXA and Hokkaido University for hosting us. We appreciate this very much. Now I'm going to hand over to our new project office team. We've been very fortunate to have excellent project office teams over the years, and we have a new pair for this meeting. So I'm going to hand over to them now.
Thank you. Thank you, Chris. Yeah, you can go. Yes, so my first thanks were first, Chris, for the presentation. I would like to also thank the University of Hokkaido and HAXA for hosting this great meeting. And now I will just try to keep on time and just remind you just a bit practical issues that we need to communicate. So first, as Chris said, I would like to introduce you to Ewald. I mean, I'm pretty sure you have received emails from him the last few weeks. So now you can finally meet him. Yeah. So the new GRIS project office is a consortium between Live Now Technology and the Institute of Ciencias del Mar in CSIC. We are based in Spain, as you know. And so these are our personal emails, but I would like to highlight that if you need something from us, if you need to communicate with us, please use the GPC address. So like that, we make sure that nothing is missed. That's the thing. So as you know, we just took in from 1st of April. So it's been a few months of hard work to prepare for the science meeting, but I would like to really thank the former GPO in DMI where we really work really close together since January and we had a really nice, smooth handover. And special thanks to Irene, who was the GPO coordinator the last few months, and we really work. It was for her support and collaboration. It was great to working with her. Also, we would like to thank as well the UMETSAT team for the patience, support, and guidance during this month. And just looking ahead, I would just say that our mission remains to support and enable the GRIS community and to ensure the smooth of its activities. So we will be open and welcome to receive your feedback, any ideas, any proposals or suggestions from all you. So just please write us, okay? So just briefly, this is something that you knew. This is some meeting guidelines. You know that this is an hybrid meeting, so to ensure a smooth and inclusive meeting, always in the room, please remind that we have people at home. Use your micro for asking or any suggestions you want to write, so use the micro. On online attendees, this is just, I would ask to please keep your microphone mute when not speaking. And if you would like to contribute, raise your hand or post any question on the session chat. We will check the Zoom meeting just to make sure that we can translate the questions to the room. As you have seen, we have dedicated questions at the end of the talk. So we will have like 3 or 4 talks all in a row, and then we will have the question sessions, and then at the end a big time for discussions. Okay. I would like you also to people at the room, check your presentation before the session starts. You can come here in the computer and check, and especially if you made last-minute changes, which is something that we used to do. So please check the final version that is in the computer. What else? Yeah. So we will use the Moodle form. For everything, you will have there all the presentations. There are special forums in each session, so there is another way to communicate with us if you want to just say something, or I don't know. This is mostly for people at home that they are in another time zone, but just use the Moodle as well. Yeah, what else? As you see, we have a tight agenda, so I would ask everyone in the room, try to respect your time, to the chairs, to be hard on that and control that we keep the time. What else? For the science team meeting, I don't know if you may not know, but we have 5 early career researchers that have been provided with a Copernicus MHI travel grants for assisting the GRIS meeting. You know as well that the nominations for new members are opened. So far, we have received 3 nominations. They will still, I mean, we have the nominations still, we will close them tomorrow. So if there is anyone in the room that wants to nominate a new member, please do it until tomorrow. On Wednesday, you will receive an email with instructions, and please, I will ask you to vote during Wednesday and Thursday, so that on Friday we can announce the results. Okay? Is it? And if you have any doubt, just let us know. The participation statistics it was already highlighted by in the talk before by Professor Ebocci. So yeah, as you know, up to 11 June we have 138 total participants, and these are the statistics of the career level and the category online on site. So as now it's nice that it's kindly of equally distributed in the career level. So this is good news that we have new people coming in the community, so there is the regeneration. It seems to be nice. Last minute good news is that finally we have received a formal a new task team for coastal ultra high resolution, which means below 100 meters. I just drive here all the objectives that they want to pursue. I'm not going to to go through all of them, and I think we need to review some of them because it might be an overlapping with other existing task team, and we need to see how do we tackle. The chairs will be Emmanuel Utret, and we have 3 nominated co-chairs, David here in the room, Andrea Prisano, and Christo Whittle or Whittle? How you pronounce it? Whittle, thank you. So if you want to take part of this task team, please let us know, write an email to GPO and to the chair. Okay, I will just tell you that. And last but not least, I don't know if you know that we are celebrating Jorge Vázquez's contribution this year. He recently retired. And there is a special web story in our website. I would invite you to read it. And on Wednesday, we will host a special session where Jorge will share, reflect on his career and long-standing in the Greece community. Another thing I would like to announce here is that we are going to restart the Greece webinar series that started the former GPO. So I will encourage all of you that are here in the room, especially the early careers, if you want to present your work, please contact us. We have already we will restart in September, and we have already two speakers already. So, but I will just encourage to send us an email to participate. Finally, I would like to thank all of you of the community, because otherwise we wouldn't be here. And the success of the community is on your work, on the contributions in the task teams as science team members. And I hope you really enjoy the week. If you need anything further from us during this week, please let us know, okay? And enjoy. This is all from us. So we are on time. We are now well, we can maybe wait 1-2 minutes. I will ask my reporter. I think I don't remember who is my. Well, I want to chair the session, so I'll be controlling the time. And now we have the task team reporting. I think the first one is Daniele. If you want to come to the stage and get ready, thank you. I think we can start even if it's 2 minutes. I think you would agree. Yeah, we can start. Okay, Daniele, the floor is yours.
Thanks a lot. Hello, everybody. This is Daniele, and on behalf of Jorge and Cristina, I will report on the last year's activities for the climatology and level 4 intercomparison task team. And so let me first welcome Cristina, who joined the chairs during the last year. So this is the list of large list of current members, as you can see from several countries and time zones across the globe. Everyone interested in joining, please contact us at the addresses you see bottom left. Purpose and objectives of this task team is to intercompare level 4 surface temperature products, and also provide guidance to users for their specific applications, and also provide inputs for improving level 4 analysis processing. So here goes the summary of our activities. So everything is stored in a SharePoint, which was firstly hosted at TMI Cloud. So thanks again to the TMI team for firstly setting this up. And we are currently migrating the material to the Live Now Tech SharePoint. And again, any access requests should be addressed to the chairs and co-chairs. We generally have 3 to 4 meetings per year. This year we had 3 meetings. In 2 meetings, we tried to address a specific request we had from the GRIS project office last year, and that came from Mercator Ocean International, Karina von Schuckmann, who asked guidance to GRIS on how to associate uncertainties to ocean monitoring indicators, how to harmonize historical SST time series with current records. And we had final meetings to have an update and wrap up of all the ongoing tasks and prepare for GRIS 27. So I'm just trying to provide some inputs of this meeting. So regarding the OMI uncertainties, we had several discussions, also revising the current literatures, strengths and limitations of the ongoing approaches used to associate uncertainties to ocean monitoring indicators. We focused on SST trends, also discussing relatively recent publication. One key publication was the one from Gobron and colleagues in 2026. In which authors provided a nice overview of a unified framework to associate uncertainties to trends. We focused on the uncertainties that may arise from measurement error, and in particular from cloud cover, and we proposed approaches like observing system simulation experiment to isolate problems arising from cloud masking. So start from a ground truth SST, inject clouds from existing cloud mask, reconstruct the level 4, and also so evaluate the differences between a reference and reconstructed level 4 SST trends as an input for having an idea of the uncertainties entity. Also, regarding the harmonization of historical SST with more recent records, we analyzed harmonization in terms of biases, but also temporal variabilities, highlighting that some historical data sets, especially before the year 2000, are highlighting larger biases compared to more recent records that tend to converge and recover before the year 2000 onwards. But also it was pointed out that temporal variability in some recent data sets looks much higher compared to historical data sets, and this is another thing we have to take into account. So the outcome of these meetings is summarized into minutes meetings that are stored on the SCTT SharePoint, and that can be used to send back specific requests and comments from GRIS to Mercator Ocean International. Regarding the wrap-up on the task advancement, we have one ongoing task on the merging of passive microwave SST into regional level 4 SST production. There is a poster in Science Session 1 regarding this topic. So this activity that I'm representing now is for Mediterranean Sea, but in parallel, we have been working with TMI colleagues for the Baltic Sea region. So you might see that in the increased coverage brought by the passive microwave SST when cloud cover is preventing infrared remote sensing of sea surface temperature. In the panels, bottom left, you see an example of multi-sensor level 3 supercollated infrared microwave in case of cloud cover in the Western Mediterranean. Differences in the level 4 SST, but also in the level 4 SST gradients are found at both large and small scales. This has to be further investigated, as for the moment we focused on 1 year. We are trying to extend also to understand the impact on the statistics, which are currently in line with the IR-only based reconstruction. And important, this activity is preparatory for the ingestion of future passive microwave SST from CIMER, and also near future ingestion of AMSR3 observations. Jorge led a study on the intercomparison of SST gradients from the Ostian and multi-scale ultra-high resolution SST. You have an example in the California coast. On the left, you see a seasonal variability of the MUIR gradients, and on the right, you see the ones from Ostia. So seasonal variability is consistent across data sets, although stronger gradients were found for Ostia. And one of the main conclusions of the study is that the difference in upstream data for the level 4 processing is crucial. In particular, Ostia considers geostationary satellites that might enhance the infrared coverage and bring to these larger data sets. Regarding gradients and feature resolution, we also had another activity within this task, which is framed within the Copernicus Climate Change Service Evaluation and Quality Control. There is a presentation on this later this week. So the main focus is in the lower part of the slide. In general, the AQC activity aimed at intercomparing climate data records on the climate data store. Focusing on the feature resolution, we analyzed level 4 fields provided from the CRISP multi-product ensemble and CCI version 2.1. Here you have an example in the Kuroshio current. And the spectral analysis is suggesting an equal representation of the large mesoscale, while the CCI dataset is bringing a bit more information towards the smaller mesoscale regime. This is also expected, also considering the ensemble average process to generate the CRISP multi-product ensemble. Although this activity for the AQC within C3S is also meant for non-expert users. So this is an easy representation of to guide users to understand which climate data record best fit for their application. So wrapping a bit this up, we had major advancement on the 2 tasks you see highlighted in red. Although there are other ongoing tasks on which we didn't have significant advancement during the last year. Validation of SST at different levels with sail drones, advancement on online visualization tool for level 4 SSTs, but also validation of SST fronts with independent data. So going quickly through to the conclusions, the current situation during the last meeting led us to think about the revision of all the ongoing tasks, evaluate potential closure of the one without a significant advancement, unless a specific interest is raised from current members or also from potential new members interested in joining. There was a discussion on how priorities should be defined within this task team, considering all the ongoing tasks, whether, let's say, predetermined activities should be agreed among task team members, or if ongoing activities, even from funded projects, could be used as an input to be brought into the task team for further development. Another point that was raised is the rotation of the periodic meetings within the task team, considering all the different time zones of all the members involved to allow everybody to attend the online meetings. This is all I have for today's report. Thanks a lot.
Thanks, Daniele. We have time later for discussion. So now I would ask the next speaker, which is who is William. Yeah, thank you, William, who will report about the coral heat stress users SST requirement. Thank you, William.
Sorry? Yeah.
This one.
Second.
Second.
Those are fantastic. Okay, so this is just an update.
Use your microphone, please.
Sorry.
Thank you.
This is an update on the task team that is more biological than sea surface temperature, but obviously we're interested in the sea surface temperature mostly because of where the task team sits. At the moment, this is the active members. We actually have a very large member list, but most of them are inactive, so I only tend to show you the people who have been actively having input into the project, well, the task team. Why do we exist? The idea is to try and help the SST developers and SST users to understand how the biological world use SST. Because of my background, this is we're concentrating mostly on corals, but we do intend to expand into all of the other biological or marine biology fields. So the whole idea here is to help the SST community understand the needs and desires of the biological community. The interesting thing is that the needs and their desires aren't necessarily a one-to-one relationship. They don't always know what they want, and they don't always understand what can be delivered. We're interested in looking at the weaknesses in the current SST products, and for that matter, the strengths as well. And so we've been well, we're high-level users as well, and so we're looking at how we can help the SST developers to understand how to improve their products so that the biological world can make better use of them. We've got three topics, or three activities. One is an ongoing activity, which is to update our user requirements and for satellite SSTs document. We have been looking at, because Jonathan's part of our team, he's keen on the idea of venturing into the biological world and how the biology and the physical SSTs are interacting in terms of metrology. So we've been looking at the metrology of a degree heating week product. And we're also looking at accuracies of SSTs over coral reefs. Specifically, we're interested to know whether or not the regression-based algorithms perform any differently to the physical retrieval algorithms for coral reefs. So I just mentioned we're actually undergoing a review of our user requirements document at the moment, and once we complete that, we'll make sure it's available on the GHRSST website. As far as the metrology of DHWs are concerned, we've got 3 people involved in that. There's Jonathan, myself, and Miguel Mies over in the University of Sao Paulo. He's our biological man at the moment. So initially we came up with this idea that the algorithm itself was the degree heating week algorithm is a pure satellite SST based algorithm. We developed an uncertainty tree where the top half of the tree is the physical, well, the algorithm, if you like, and the bottom half was the where the biology came in, which is mostly to do with the ground truthing. However, we come to the conclusion that we're a little naive and a bit too simplistic. And the reality of life is the uncertainty in this algorithm involves biology in the algorithm as well. And of course, the ground truthing is almost all biology. So we're currently having a series of meetings. We too are having problems with the fact that one of us is in Brazil, one of us is in the UK, and one of us is in Australia. And so coming up with times when we're all available is interesting. But we're working on redesigning this, and by the time next year rolls around, and we're in France for our meeting, we'll have an update. So the last task that we're working on is the accuracy of SST retrievals over coral reefs. And for people that aren't interested in coral reefs, you can take this as shallow water as well. It'll be the same story. So the aim of the project is to compare regression-based and physical retrieval algorithms over coral reefs, especially day versus night. Now, why I say that is, turns out that recent research has showed that diurnal variation is highly linked to the evolutionary-driven biology that corals have that allow them to be resilient to heat stress. So in our attempts to try and map where resilient corals live, this is a key input. So our two data sets that we've been looking at is AXPO, level 3 products for regression-based algorithms, and CCI level 3 products for the physical retrieval data. As you might recall, last year we got to the point where we were wondering, well, basically we compared AXPO, which is a reprocessed product, to the CCI product, which is an algorithm that could be run in real time. In other words, it doesn't get reprocessed. And what you've got is, let's see now, AXPO's on the left, and CCI is on the right. This is all the data that we had available to ourselves in the top two graphs. You can see that AXPO in this example, not all examples, is much tighter around the one-to-one line than CCI, but there are a lot more points in CCI, probably due to cloud detection algorithms, or the differences in the cloud detection algorithms. So in the bottom, what we did was we just used the data that we had where we had a point in both data sets, and you can see that it's tightened up the CCI data considerably. So the question was, what's going on with this reprocessing? Is there a difference between their near real time and their reprocessed data? So AXPO has near real time data at the L3U product is available for 2 weeks. The reanalysis data turns up at the 6-week period. In other words, 4 weeks after the near real time data disappears. There's a 4-week gap where there's no data available at all. So the reanalysis is archived, and the near real time data isn't archived at all. It's only available for the first 2 weeks. The file names are identical, which is a bit confusing. So what we did was we collected for a year, basically the last year, we collected all the near real time data so that we could compare it with the reanalysis to see what the difference was. And these are the differences for the daytime data and the differences for the nighttime data plotted. There's not a huge amount of difference, and the statistics show you that we had around 3,000 points for each day and night. The mean difference was very small. The median was 0. The RMSD was pretty much identical to the standard deviation, in other words, very low. And the differences, 95% of the data is within 0.1 of a degree difference. This is derived from 6 sites, one in Western Australia, 3 from the Great Barrier Reef, and 2 from the Florida Keys. So they're scattered around the world fairly well. And the interesting thing too is that there's approximately 5% of the data in the daytime, in the near real time data doesn't exist in the disappears when it gets reanalyzed. And the reanalysis data has about 5% more data, new points. And this is the same for day and night, roughly speaking. It varies a little bit, but not too much. So what we came to the conclusion of was that there's no, from our perspective, there's no practical difference between AXPO near real time and AXPO reanalysis for either day or night data. So we've decided that we can go ahead and do a more comprehensive analysis of AXPO and CCI over corals for using the reanalysis data and not worried that we're getting a different result because of the reanalysis. And so we need to use a lot more points, and then we'll report back next year. That's it. Thank you.
Thanks, Nim. So next talk is Noel. Yeah. Let me see. Yeah. So it's about the color palette testing.
Thanks. So I'm going to present you the work that was done by the color palette task team, a short-term, small task team, I have to say. So for those that were here last year, you might remember I came with a question from OSISAF as provider that display their SST to users to have a common palette, and that to have a recommendation of common palette that we could use. Of course, nothing mandatory, but and there were no. So we decided to start a task team on that. I'm then chair of this task team together with Vipke, so really OSISAF chair. And then we were joined by Benjamin Loveday from UMedSat, Christina, Owen, Christo, and Werenfried, and we have 3 observers as well from both UMedSat and Copernicus, actually. And we aimed at finding what would be the best color palette for displaying SST. Coming to the point that there is no consensus on a way to represent SST. I mean, we already had a display today with a few presentations. Everyone is using different palettes. Some are quite problematic for SST naive public, for non-specialist. So the last consensus, if I may call it like that, would be Medspiration. And for a non-specialist, it's not obvious, definitely not obvious. I mean, it has its good point. It's not pure critics. The Medspiration then, as jets that we already see today, is causing accessibility issues for colorblind people. Just to remind, it's about 8% of male, of European male population, so it's not a small part of the population we're talking about. And there was multiple isolated effort to build on color palette. So we have a wide range of color palette accessible that we can use. And of course, everyone is using its own. And then people start developing their own to add some more mess. Then you sometimes find, I remember one presentation last year where even on the same slide, we had different color palettes. So, we try to find a need, we try to answer the need for a common reference to exchange publicly. Once again, the point is to give the possibility to the one that wants to have something that will make kind of a consensus, if I can call it like that. So it's been a tight year because I wanted to come here with an achievement. So I've been a bit pushy. I see people laughing. So we start with a kickoff meeting in September, and the first point was to think about the requirements of this kind of ideal color palette, which doesn't exist. And then we were exchanging on shared documents, and we had 2 meetings to speak about so the main problematics were around accessibility. The color has to be obvious. And this is a tricky point because it's completely subjective. The fact that common people in most culture today say that blue is cold and red is hot is completely subjective. It's cultural. Then we had to as well emphasize on contrast and brightness. We had to get something that will be accessible, adaptable to scales, and we had a high latitude girl with us for that point. And then we tried, to be honest, we did that a few, but we tried to have no data color to help visibility. The second task was then to gather the propositions. So we had 4 color palettes that were developed, 2 by Wipke, 1 by Benjamin Loveday, and 1 by myself. And we selected 8 amongst the existing palettes that we consider were interesting for some reason. We decided, so Wipke decided to drop her color palette, so we end up with these 10 color palettes to compare. And then the next task was beginning to select the proposition. So for that, we start by looking for objective criteria. So Ben developed a Python-based routine to give score assessment on all of them. So there were 5 score, one on perceptual uniformity, 1 on lightness, 1 on so the possibility of black and white printing the scale. 1 on HUE, so the jump, the discontinuity, which will make false gradient appearing. The semantic correctness, so this blue and do we understand? Algorithmically, is that clear that the hot does feel hot? And colorblindness, colorblind friendliness, which was probably one of the most important objectives. I'm not going to present in extenso the GitLab. If you're interested, please go to follow the link. And we ended up with a score for each of them that you see here. On the right column, you have an average notation taking into account all this scoring. But we were missing what is probably the most important for SST displaying, right? The spatial gradient rendering. And for this, we didn't find an objective way of scoring it. So what we did was I asked to all members to rank, to score, as a teacher will do, so subjective way, of course, which each of the palettes, and we did an average of the notation, and believe me, the notation were not the same for everyone, even if there was common trends, of course. And we ended up with that, which actually give that if you see that the expiration, which was the lowest scoring for the whole objective criteria, but was developed specifically to render the gradients, of course, had a very good notation, but it didn't change much the notation. Of course, this was tool to decide which would be for us the best one. It's not the scoring is not all. Don't get afraid of getting Viridis as a proposition. And then we went on selecting a proposition. So each one had to rank all the palette from 1 to 10, 1 being the one considered as the most appropriate one, and 10 as the less appropriate one. Why that? Because, and it happened like that, the first choice of everyone might not be consensual at all. And probably the best choice might be the second choice of everyone. That's actually what happened. So I told you that we selected some palettes because they had interest. We did select Viridis. I guess you will all agree that it's not spontaneously representing SST. Now, by the scoring, it's the best one. But as you see by the vote, it is not anymore the best one. The color doesn't, in a subjective way, the color doesn't correspond to SST. I guess that's quite obvious. Then we had, at the end of the voting, we had the rainbow palette. So one of the main reasons why they were not well selected, I know they are widely used, right? But one of the reasons why they were not selected is because they are not obvious and they are not easily accessible for colorblind people. So the team considered them, even Metspiration with its high gradient rendering, are not the best solution to represent SST for the general publics. I'm not talking about between us, of course. Then brewing palettes is not an easy task. We knew that, but we wanted to give a try. And yeah, definitely, it's not an easy task, right? You can't brew a palette, decide that you become a specialist of palette creation in 1 month. But it was interesting to actually see that our results were quite spread. So no one voted for its own palettes. That's good. And then the other group beside the rainbow one, I'm late already. Okay. The second group, the one that are the widely used, and I was not expecting this kind of result actually for the red, yellow, blue. They are polarized. Either people like them, either people dislike them. So this I was expecting that for the perceptual uniform one, the thermal and the plasma. But for the red, yellow, blue, I was not expecting that. I would have expected that it was more on the top list, and it was either 1, either 7. And then the consensus goes, so yeah, there is a point, red, yellow, blue is not scoring very good for accessibility and for gradients. So it's the choice, all the scoring that we did made the choice being more at the bottom. So the consensus came a bit surprisingly from one proposition of Owen right at the end of the of one session, of one of the last session. And these two were doing all the voting process on the top list. And you see that to one exception for everyone, one different person every time, they all were on the podium of every people. So, and Omeya Rainbow was one step beyond Roma, always coming before Roma almost every time. So we come with a proposition of using Omeya Rainbow. What is ND if it's already available on Matplotlib? Why? It has a good spatial gradient rendering. And last week, people tell me that I should display that it is color blindness friendly. That's the type of schematic that we were using for or taking our decision during the vote. And you can see that if it doesn't look at first as colorblind friendly, but it is in fact. It was made for being colorblind friendly. So, and it is obvious, like the cold is blue, the hot is red, which makes sense for every non-specialist user. Yeah. So what's coming next? So we are here coming with a proposition. We'd like to have feedback from the science team, of course. And then we are expecting the task team to be over next year, at the end of next year. And our next work will be to advertise this color palette if the science team agrees, of course. And that's all for me.
So thank you, Noel. We will wait for the discussion later if you want. We move with the next task team reporting, which is high latitudes. Pia, welcome. I want to suggest you, I mean, we can discuss now in this discussion session, but if you want to raise any concerns about the color palette or other any issues, I'm going to just remind you during all the week that you have the email, you have in the Moodle, you have the forum, so feel free to contact us in any way, okay? Yeah, well.
Thank you. Yeah, I'm here to report on the high latitude task team together with Steiner Eastwood. And the high latitude is discussed to be reopened at GHRSST27 in Montreal. And last year we have finalized or presented the finalized work plan in Copenhagen. And here's the motivation why we need a high latitude task team. And that is generally that SST in high latitudes, that's very challenging. The products we have, they have the largest uncertainties and show the largest differences in the high latitudes. And that's due to a number of factors, one of them being the sea ice and the persistent cloud cover for the Arctic. And also we have very limited in situ observations in both hemispheres. And the high latitudes task team is also focusing on the sea ice surface temperatures, IST, and that's much less mature than SST. So until now, the definitions have been lacking. And also there are validations and comparisons of the existing products needed to better characterize and understand the products and their uncertainties, which is also very challenging due to the limited in situ observations. And as you can see from the map that shows the trends in open water days, there is also a need for consistency or considering consistency between the SST, IST, and the sea ice concentration fields in high latitudes. And also, finally, there is a need to understand and have good definitions of the marginalized zone. So here's the long list of current members. Please reach out to us if anyone is missing or if somebody wants to leave the task team. And this is the main objectives that we established last year. So it is to exchange ideas and to high latitude SST and IST and to validate and improve the products at high latitudes. And then to integrate the consistency among the SST, IST, and sea ice concentration products, and to facilitate the use of existing and new in situ observations in the high latitudes. So on to the activities. So we decided early to split the task team into 3 tasks. One that was focusing on validating and improving high latitude SST, and another task focusing on the IST to validate and improve that and develop definitions. And finally, our last task team focusing on, you could say, the marginalized zone, so the consistency between SST, IST, and sea ice concentrations. And the idea was that these 3 tasks, they should actually run in parallel with the sort of same focus on each of the tasks. But that's not how it has turned out. I think for the past year, we have focused mainly on task 2, as you will see in the following. But in any case, we will provide an overview of the task. Standard, we want to present the one on SST that you're leading.
Yes, so for SST, we had many good ideas on things that people would like to work on, or to at least enlighten and look into, improve and develop SST retrieval for high latitudes, list and map differences of different data sources, validate and compare products, and also in general work on the matchup database to validate, and some advices or best practices on validation in polar conditions. There's also a task on diurnal warming in polar regions. We haven't really started on that, but there's been a few papers and interesting studies on that previously, and we would like to catch up on that. And also, the most important thing on in high latitudes is about cloud masking, ice masking, how to get the best data whenever there's no clouds. So we need to do more on improving, and also the cloud masking itself, but also quality controlling of the cloud mask. So this is just, as Pia said, we haven't had many activities specifically on this task yet. There's been more focus on the ice surface temperature issues. But we'd just like to mention 2 projects that has done some work. The CipherMask project is a Copernicus EUMETSAT project, where we are working on the validation of cloud mask over sea ice and polar ocean for SLSDR using the Calliope LiDAR. So with historical data, that's the bar graph you see here, where you see the validation results as in bright colors, the false alarm ratio for clear detection, and in light colors, the probability of detecting cloudy pixels. We can see the better qualities of the masking over water than over ice, and specifically the poor quality of at nighttime over ice. This is for the no-casting PPS software, but I think in general, doing cloud masking over ice is difficult, and here we have a number that tells us how difficult it is. Another project we would just to show you some examples here is the OSAF. We've been doing some work on the discrimination between ice and water, so I call the ice masking here, at nighttime, using the WIS instrument, where you have the 8.5 micron channel. You see the 2 pictures here, daytime on top and nighttime at bottom. And in both cases, you see the difference between ice and water. But at daytime, it's more obvious. But there is a signal at nighttime, which we can use for ice-water discrimination. So come and see me at my poster for that.
And I can take that one. That's something that we are looking at DMI. We are validating our SST products, and these are the latest results of the validation of our microwave SST CDR from AMSA 2 that has been validated against drifting buoy observations. And yeah, we can see from the map of robust standard deviations that the high variability regions clearly stand out. But what we are interested in here is what we see in the high latitudes. It looks like we have a warm bias in the high latitudes. So that's opposite of what we see from the infrared SST. And another thing that we're looking at DMI is that we're preparing for the next generation of passive microwave radiometers. And we are doing that in 2 projects, in the OSISAF project, where we have to produce near real-time level 2 products for SST and IST for AMSA 3. and in the SIMA-L2 pad, where DMI is responsible for the SST and lake surface water temperature and IST processes. And Amy will tell you a lot more about that and the status in her presentation tomorrow. So now we're moving to the IST-focused task sim, and that's where we have spent a lot of time, in particular on task 2.1. And I will show the results in a minute. So we have spent a lot of time on the definitions and coming up with a reference figure for IST, similar to what we have for SST. And we have also, from the DMI side, looked quite a bit on the skin to 2 meter conversions. And then, yeah, we're also comparing different IST products. Yeah, and Steiner already gave you the update on the cloud masking OIs. So for the IST reference figure that we spent quite some time on, it started last year in Copenhagen, where we looked at these IMB profiles of temperatures. These are examples of 2 buoys in the Arctic Ocean, and we have the temperature profiles for different months. The crosses, that's the air-snow interface, and the triangles is the snow-ice interface, and then we have the bottom of the ice represented as the circles. And at Copenhagen, or at the GHRSST meeting in Copenhagen, we had a drawing competition where we came up with the first go on how we would make such a schematic. And the 3 winners from that competition are listed here. And following that, we had a lot of digital versions. We were working in a Padlet, many versions, some more complex than others, and a lot of discussions. And we produced some animations to better understand the shaping of the profile over the course of the seasons. And that's running for 1 year. I don't know if we have time for that. But now I think that we have agreed on 2 final versions of the figure, one simple schematic and one a bit more complex, where we also include melt ponds and the disappearance of the snow during summer. And these are the 2. They are still, living figures. But here we have identified 5 IST variables, as you can say. We have the skin temperature, and then we have a subskin temperature, which is the microwave temperature. And you can see that that's not at a fixed depth. If you see the purple stars, you can see that the signal changes over the course of the season. You can see it more clearly in the one where we have the emitting layers marked. And then we have the snow-ice interface. And then we have added an IST depth, which is meant to provide the link to in situ measurements measured by thermistor strings. So we have positive values into the ice and negative values representing the snow thickness. So that's what we propose so far. So this, for the simple case, it's supposed to represent a multi-year sea ice flow with this constant snow depth and sea ice thickness. And then the other one is representing or showing that it can be more complex with that. We can have melt bonds, etc. And still, if you have any comments for that, please reach out. And then from the DMI side, we are also looking a lot at the different IST products. More IST products are coming available, and we have also expanded our in situ database from DMI, now also having the mosaic data in there. And these figures here, that's a comparison of the LST CCI MODIS data and our ST data. And yeah, we will extend this to other sensors and more years. And then we are working, as I said, on this skin to 2 meter conversion at the DMI. And this is something that we are doing in an ESA project called Multikusuma. It's an extension of an earlier project we had called Eustace, where I had a paper converting the skin temperatures into 2 meter temperatures using a simple regression model. But now a colleague of mine is using machine learning models to improve this conversion, and it looks very, very good. We can see that we have a clear improvement, in particular during summer. Yes. And thanks. And yeah, you can see the results of it here. To the left, you have the IST performance against in situ 2-meter air temperatures. And you can see that we have this cold bias, part of that being explained by the actual difference between the skin and 2-meter air temperature. While when we then convert it to 2-meter air temperatures, we get rid of this difference, and also we get improved robust standard deviations, as you can see from the table. For the mic, I show shortly.
You have 2 minutes.
2 minutes. Okay, I'll be quick. So, improving the consistency between SST, IST, and CS concentration products. So it's all about the marginalized zone, and we want to come up with a way of defining the marginalized zone for our purposes, for our temperature retrievals. So, and then defining a marginalized zone temperature, and for that, coming up with a reference figure to understand marginalized zone temperatures. It's not a big. It's a small part of the global temperature regime, but it's for us up in north, understanding the difference between the ice and SST is important. So we want to also be able to explain that with figure. So we have started to discuss this. We had a discussion at the group task team meeting where I gave a presentation about how we can look upon it from the level 2 viewpoint, but also level 3 and level 4 is different because you have different resolutions, different both in time and space, and how to deal with this. So these 2 figures is just to show, starting from idealized case with ice and water, how does the different regimes work on the temperature retrieval. It looks fine at the daytime, typical infrared situation here, but all neighbors of the transition between ice and water will be partly covered by ice or water. So you need to define, let's say, a local marginalized zone as something in between water and ice. So the top figure is all the neighbors over ice, which are influenced partially or less by the water, and opposite at the bottom here, how the ice influences the water. And in a way, locally, this defines a sort of a marginalized zone around on the level 2 part. But it's different in infrared and in microwave because of the resolutions. And then how does this affect when you aggregate to level 2 and then to level 3 and 4, and more complex when you combine microwave and infrared. So this is what we are working on now, and try to find up some reference figure on this, and trying to be able to explain in a simple way this complexity. Yes. So yeah, more about what else you can see from our task team members here. Presentations and posters during the week are listed here. Yeah.
Okay, thank you. So we have now like 15 minutes for discussions, questions for the task team members. I would like to, to encourage you to start the discussion. I hope you had a coffee morning. I don't know, otherwise, yeah. Just go approach to the micros. There are 2 micros in the room, please.
William, if we filled in the 4 weeks on a non-operational, distribution, would that help? Or did you just do it once and you're done? Would it be good to fill that in?
Just talk to the micros, please. Otherwise, at home. Yeah, thank you. No, it's just I was preventing.
So the question was, would it be helpful if Expo if Expo had the 4 weeks there as well, and the answer is not for what our current purpose is. For biological use, we need level 4 products, so we would never use a level 3 product. We're only using the level 3 product because it allows us to compare the 2 algorithms. You know, comparing level 4 products is comparing a whole heap of other things, not just the algorithms. What we concluded in the end, what we would have liked to do is to compare the near real time with CCI, because that's comparing like with like more. But what we concluded was, there's functionally statistically no difference between the reanalysis and near real time. So if I were to say anything coming out of this, would be to ask you whether or not the Expo team have actually looked carefully at the value in doing the reanalysis in the first place, whether or not we're gaining anything from it. Seems to me that an analysis of those differences that I found needs to be done to understand whether or not there's a gain in it. It seems to me, statistically at least, there's no gain, so why do it?
Yeah, but the reanalysis kind of matches what the near real time is. You see what I'm saying? If there was an advance in an algorithm, then we would reprocess and make everything come up so that they'd be consistent. So that's kind of by design. I mean, it may not be. I don't know which versions you used nor what the specifics, but anyway. But it was a one-time study, and you don't need to have it routinely and holding on to it.
No.
Wouldn't be any use.
Not useful.
Okay, thanks. Good. Second, I have a second. Go ahead.
William, you said there was no difference, but I mean, there was a very slight difference in the stats, but that 5% that you mentioned in pixels that were in one and not the other, that's not nothing. From an algorithm, it's essentially identical. So yeah, I agree that someone should look into why there are 5% differences in things which are supposedly very similar. That's, I'm going to say, quite a large number from something that's coming out of essentially the same processing system. That's I don't know who. Anyway.
And it was both ways, roughly speaking, and it varied between 3 and 9%, depending on which patch we're looking at. But basically, 5% would disappear, and a new 5% would reappear. So it didn't really change the numbers of points we had, but it changed where some of the points were. So very interesting.
Just to follow on the discussion, otherwise, because there was another hand raised there. It's the same? No, you can. It's just if we change topic or not. It's just to give you the
different topic.
Okay, so we move to Chris, and then you come in. Okay, thank you.
Thank you. I have a question for the intercomparison task team, Daniele. Thank you very much for your presentation. It was on the ocean monitoring indicators uncertainty. I didn't quite understand how far that had got to and whether you'd managed to answer some or all of the questions they had. So that's question one. But also, were the uncertainties in the products that are already provided useful, or did you have to invent new methods?
Trying to answer the first question. So up to now, we only had one meeting, which ended up with a first round of discussion with potential ways forward to address this question. And what happened in reality is that very soon after our discussions, we saw appearing the paper I mentioned during the presentation from Gobron, which basically we think provided a lot of answers to the discussions we have been holding. And in particular, one of the things we proposed was somehow to isolate one of the issues arising from the measurement errors in contributing to the uncertainty. At least we focused on SST trends as a starting point. So that is one thing that at least currently in one of the methods that we revised was missing. And that was our proposal to try to address this issue. So isolate at least cloud cover, as I guess many other factors can contribute to the measurement errors. We didn't tackle, so we didn't have the chance to follow on from this. So what we have from now is a report in the form of a meeting minutes that could be used to follow on and then provide an answer, comprehensive answer to Mercator Ocean International.
My question is for the color palette team. Hi. Did you show any of the color palettes to non-SST specialists, or maybe people, users of SST who are not part of GHRSST?
Yeah, I'm not part of the science team. I'm not a physician even. So I can consider myself as a non-SST specialist. And my task within OSISAF is to be in contact with, to make the contact between the scientists and the users. So yeah, we've got like, so I remember what were my feeling when I first look at my inspiration and say, what the hell? And how much time it took me to understand it. And so I'm based, yeah, I based on my, all the others are specialists of SST, I'm afraid, but I probably am the non-specialist one in the team.
I don't know. Yeah, Joanna.
Thanks. Just to add on to the OMI uncertainty discussion, and I think this is pretty recent from Friday, there was Mercator Ocean is hosting this OMI specialist working group for their OMIs. And there is, from this group, there seems to be an idea that it's a good idea to identify uncertainties in OMIs, to do ensembles of the OMIs. And this is a way they are trying to go. And for some of the products that can work, where you have similar type products, but they are even thinking of blending in reanalysis and satellite datasets, for example. So it's not really clear where this is going when it comes to OMI uncertainties, but this is something they're also thinking. And I don't know if there's something we need to discuss there on providing some GHRSST recommendations on if this is a good idea or not. But it could be put up for further discussion. Thanks.
Yeah. So my question for William for GHRSST. So you talked about daylight and solar thing, the diurnal warming and association with the coral heat stress. And most of the heat stress products are derived using level 4 product, which are mostly done using nighttime data. And if there is a daytime and then the relationship with the coral heat stress, we should be using level 2 or level 3, the day product more. Is that right?
I'm not sure. Can you
so
simplify your question?
Yeah, so all of the level 4 products are made with using only nighttime data, but you are saying there is a coordination between daytime data and coral heat stress. So then we should be using the daytime data rather than the nighttime data.
I think I'm not. Are you asking whether we should be using one or the other, daytime or nighttime?
Yeah.
And the answer is at the moment, none of the products the only source of global products at the moment in an operational sense comes from Coral Reef Watch. Coral Reef Watch use nighttime only, which is the sensible option, as it turns out, simply because AXPO on some satellites in some locations have a real problem with daytime data for some reason. Haven't looked into why yet. But CCI is so much more consistent day and night. So they're anomalies that are daily, if you like, but it's only using nighttime data. Why the need for day and night data is, first of all, if you could resolve diurnal variation, you could get a daytime value with less cloud in it. That would be good. But more importantly, it turns out that diurnal variation, understanding diurnal variation for corals, tells you something about their physiology or their genetics, if you like. And it is a way of tracking down some of the more resilient corals for heat stress. So to have products that can give us daytime and nighttime separately will allow us to look at the diurnal variation and hence derive maps that might help us understand where the special corals are and which ones we should be looking after. Having said that, ideally, it would be great, and Gary's been working on this for donkey's years, to have a diurnal variation product that literally maps hourly diurnal variation. That would be fantastic. Over a coral reef, very hard to do. So, I mean, it's interesting. It's sort of slowly converging on what we need, but we're still a long, long way away from it. Going higher resolution than 5 kilometres starts to get total aliasing involved, and you need much more temporal resolution in the products. So interesting to see how the coastal high resolution guys go with their task team, because they've got massive problems with dealing with the fact that they don't have temporal resolution good enough. Once they, and how in fact temporal resolution once again feeds into the diurnal variation with that high resolution story. So yeah, we're all on the right track, but we've got a long way to go yet.
Yeah, thank you.
Okay, yeah, but it was one question there. Okay, we are just, I mean, I think we will keep the discussion because I think it's interesting, but we are just on our coffee break time. But I think, yeah, I think it's interesting. I'm not going to kill the discussion now that it's interesting, so.
Thanks. Sure. A very silly question, maybe. Why not geostationary only? I mean, it used to be that we didn't have enough data geostationary-wise, but now we are in 2026 and we've got a long, long archive of geostationary as well. It's level 3. Of course, you will have clouds and stuff, but is there any value there?
So the analysis that we're doing is questioning the algorithms that are being used, so it doesn't require high temporal resolution. Temporal resolution can come from geostationary satellites, you're right, and I guess it's up to the level 4 producers of the products, such as Andy, for instance, to pull their finger out, as it were, and stop lumping everything in together and ignoring the fact that there's a diurnal variation. Otherwise, the Coral Reef Watch product wouldn't be just nighttime only. The whole idea behind that was mine 2 decades ago, where I insisted on nighttime only because I wanted to dodge the problems of diurnal variation, and I wanted a consistent day-to-day temperature. Now that we have satellites up there that are giving us data every 10 minutes, for instance, we probably can do diurnal variation properly. It's just that it's not being done. So that's probably a good comment to the entire GHRSST community. This is something we need to head in the direction of. If we're going to understand the impacts of climate change on the biological world, and it's becoming more and more important, diurnal variation in our products is very important. And Gary will pretty well tell you, you can't model it. You've literally got to measure it. Models only help with filling in some gaps. It doesn't resolve the whole problem, unfortunately.
I think it was another, I don't know if someone wants to, okay, we are running, maybe we can just follow at some point I need to cut the discussion, although it's interesting. I don't know if you want to, is it related to that topic?
No, it's not.
Shakila, is that related? Okay, so go ahead. Your intervention, then you, and we need to go to coffee, otherwise we can keep it and skip the coffee.
Okay, I'll be quick. So just going back to diurnal correction. So we are working on, at NOAA, we have both the level 4, working with Andy Harris on the geopolar blended SST, and we have the 3 flavors. We have the day, we have the night, day-night, and then we have the diurnally corrected one. And I know Andy has been working a lot on bias correction work, but you're saying in general for the diurnally corrected SST level 4 work that's going on, you're not happy with the current product, or have you examined that product at all?
It hasn't been thoroughly examined. If it worked, it would be good because it will improve the density of data. But having said that, also if it works, then clearly you can reverse engineer it and come up with a product that actually tracks the diurnal variation through the day. And although that would swamp the users with data, that would be fantastic. So the challenge then would be how on earth do we present that data to the users without blowing their minds up with data? They already get freaked out with remote sensing data.
Okay, Andy, it's related, I guess, for...
I mean, there is a certain irony in being asked to remove diurnal variability, and then when you remove diurnal variability, people say, oh, we haven't looked at it, please put it back in again. Yeah, it is, the Met Office were doing quite a nice diurnal skin variation product, but they've stopped doing it, and I don't know if we can possibly find out why, because we are okay at modeling, but we're much better at observing it. And it's partially down to the models and partially down to the fact that the forcing fluxes are so hard to get right. And we are right down in this, the laminar case, and NWP is not good at that area because essentially you're looking at, largely looking at scatterometer data, and it works great down to about 2 meters per second. But what we really care about is 1 meter per second and 0.5 meter per second and no meter per second at all. And they basically have no sensitivity once you get down that low. It's just residual wave action. So that is the big problem. And so the ability to observe it essentially, and then go ahead and predict would be good. But then, of course, you're worried about, I mean, I've been to the Barrier Reef, and I know full well the corals are well below, most of the time, well below the area where significant diurnal warming is taking place, if you see what I mean. So you've got all sorts of other things going on. You need to know that vertical structures. You don't just want, say, hourly skin temperatures or hourly whatever. You want hourly at whatever depth is the corals at as well, which is, that is just a massive amount of information, so far removed from a single global daily 1/20th degree analysis, SST. You know, it's a specialized task, requires a lot of effort.
Yeah, I do agree. William, I need to cut it here, otherwise we don't drink any coffee.
I can be quick.
Last question. No, I need to, I'm sorry, forgive me. Last question here, and we go for the coffee, okay? Thank you everyone for the really interesting discussion. Go ahead, please.
I'll make this very quick. I've got a question for Pia. It's pretty cool to see the IST profile figure that you worked on. I was wondering 2 comments. One is it, would you think it might be better if you remove the spring and autumn profile lines just to keep it simple? Second question is it possible to add a number, like a reference number, rough number on the y-axis so that people know the depth of the CIS to some level?
Yes, thank you very much for your comments. So I'll start with the last one for the depth, and that is something that we have discussed. And yeah, I think, yeah, the main argument, I think, is yeah, to keep it simple. So we yeah, and applicable to all multi-year sea ice flows. So yeah, that's the main argument. And I think for the SST reference figure, it's to begin with, they also didn't have a depth in there, but I'm open for it. And for the seasonal profiles, I think, but that's my perspective. It's good to have them in to see how, I mean, so you don't just have the transition points in summer and winter, but you can actually see how the transition is going on. When you are after summer, you're having the cooling from the air. You can see how it moves, how the profile changes. So I think it's nice to have them in. But yeah, I do see some complications of it, and in the perfect world, we should probably have 4 or more figures per season, so we could also change the snow depth and ice thickness accordingly, and have the melt ponds represented right there. That's kind of living its own life to the right of the figure. But good points. Thank you.
Okay, so thank you, everyone. I would ask you for applause for all the speakers and all the contributions. And yeah, so we are now having the coffee break, and the next session is starting at noon. Okay, so try to be punctual. Thank you. At 12 at noon. Yeah, 12. Yeah.
Hello. Dr. Kameter is online.
Yes, I'm here. Can you hear me?
Yes. So could you share your screen?
Let me give it a go. No. Share. Let me know if you can see that.
Yes.
Oh, great.
It's coming. Okay. We can see your screen is projected to the conference site. Okay. So.
Wonderful.
Yeah, perfect.
Okay. Just let me know when you'd like me to start because I'm on a
Okay.
laptop, so I
Okay.
lost
So
the
in
screen for
3
the
minutes,
actual
I
Zoom.
guess.
So just let me know when you're ready.
Okay, please stand by.
Yeah, no worries. Take your time. No worries.
Test.
Testing online. Can you hear us? Can someone online confirm that they
Yes,
can
can
hear?
you hear me?
Okay, thank you.
Yes, can you hear me? It's Danielle.
Hear you.
Thank you.
Yes.
Okay, may I have your attention? We're ready to get started. Could you please take your seats? We're going to get started with the agency report section. Welcome everyone online and everyone here in the room. We're going to start at, it's 12:03, our agency highlights section. So to begin, we have Daniela Carpenter from the Naval Oceanographic Office.
Thank you so much for the intro. Hello, everyone. Go ahead, Shigila. Did you say something?
Oh, no, go ahead. You're good. Thank you.
Oh, okay. Sorry. So as she said, my name is Danielle Carpenter, and I am the Ocean Measurements Division Technical Lead at the Naval Oceanographic Office. Also dialed in is Miss Jessica Schroeder, who is currently the acting MCSST project lead. And we also have Pedro Rivera, who is our software support. Normally, when I've done this slide intro, there's been about 8 names on this slide, but due to funding cuts and retirements, the team is now down to just us 3. So that group email you see on the screen is the best way to reach out to any of us if you have any questions. I'm moving through the slide. If there's a really significant delay in the slide change, just give me a shout and I can take a pause until it changes. But for our current status, we are still working the L2P and L4 GHRSST level products as we always have been, so no changes there. As far as the GHRSST data that we acquire, there's 5 different satellites that we receive from all of our partners who are present in the room, so thank you very much. All of this data gets assimilated into the Navy ocean circulation model for the forecasts out to the fleet. Additional products that we create that are available if anyone wishes to receive them. We currently have 4 different products that we have readily available on standby that are at the bottom of the list there. So for updates, we currently have 4 satellites that we are operationally processing that are just awaiting patching to be done by Fleet Numerical from our sister command in order to ingest them into the forecast models. We are interested in migrating to use of full resolution data, but right now any new development is currently paused due to lack of personnel and due to changes with the government administration that is still coming down the pipe. Also, any R&D work that was performed at the Naval Research Lab is also currently paused due to lack of funding this FY, and we are hoping to be able to return to normal work as far as any kind of innovation and processing enhancements and new data feed ingests in the next fiscal year. As far as future work that we are doing, we're just awaiting data availability as well as testing of the MTG, WSFM, and GOSAT GW satellites. We're also awaiting any kind of future launches that are due to happen in the future, such as Sentinel-3C and EPS SGA-1. We are also tracking 15 more satellites after the end of FY26 that are scheduled to launch sometime between then and FY35 to be able to ingest into our processing. Lastly, we are also monitoring the movement of the old GOES 14, which is due to be the next EWSG3 to continue to provide the Indian Ocean coverage that we have been looking for. Discussions are currently underway, and we've provided justification from the Navy side to advocate having GOES 17 become EWSG4 in the next few years. Lastly, a quick note for everyone. Prior to or after I made these slides, we did hear from John Francois Cayula, who we've worked with at the Naval Research Lab for many, 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 many years. A lot of people in this group are familiar with him. He will be submitting his retirement paperwork during the summer. So, yeah, he will miss everyone greatly, and he wanted me to relay that message to everyone. So that's it for me as far as an update.
Thank you so much, Daniela, and thank you for the note on John Francois. Next, we'll have
Sure.
Yeah, yeah. John Francois, okay. From IFRIMER.
So yes, so it's an overview of IFRIMER-related activities. So for many years now, since the beginning of Medspiration project in 2004, we have been producing multi-sensor level 3S and level 4 products, both at a global scale with 1.1 resolution and that over different areas of interest with a higher resolution, so about 2 kilometers. So it's been produced continuously from NRT data, so using infrared polar orbiting and geostationary data, but also microwave from AMASR. And we are also producing some reanalyses in the context of Copernicus Marine Service based on the CCI infrared data. So the processing chain is called ODC, is based on optimal interpolation for the NRT and on a Kalman filter for the reanalyses. And it covers, as I said, different areas. So the global and Northwest Atlantic area are in fact included in the Copernicus Marine Service, and it comes with some visualization services, and the data can be accessed from the CERSAT, which is IFRIMER satellite data center. So the main evolution regarding this multi-sensor data set this year were so adding VIRS on board NOAA 21 in last November. We are also now transitioning to the new collection for LSTR dataset, and this summer we will also transition from AMSR2 to AMSR3, and we will include also MTG before mid of next year. We are also now working on new machine learning based methods like 4D-VANET to intercompare with current approaches that we've been using so far. And if successful, this will be probably replace the existing method, and it would also allow additional areas like French overseas areas, thanks to faster computing time. We are also, from this multi-year analysis that I showed, we are also producing these ocean monitoring indicators for the Copernicus Marine Service. We are also producing some in situ validation dataset dedicated to the validation of surface sea surface temperature. So it is based on for the input data on the Copernicus in situ TAC main archive, which is also hosted at IFRIMER. So using the drifters and GO and moorings. And we collected the different practices and procedures from different European partners for the data editing, for the quality checks and so on of the data, the selection of the surface data. We are also using existing assets such as a buoy blacklist provided by Météo France or UKMet. So there is a version 2, which is currently available on FTP, and we are working on version 3 planned by the end of this year in the context of OSISAF, with improved editing, in particular for high latitudes, and also to produce a multi-year reprocessing for the validation of CDR datasets. So it will be all available in SCDF and Parquet format. We are also producing some supporting software, and so in particular in the context of support that we have with the Copernicus program through EUMETSAT. So this is a Felix software that is an open source Python-based framework to produce the satellite to in situ matchups. So it's not only for SST, but it can be applied to any variable. So it's been used for many projects now. It's been deployed at IFREMER in EUMETSAT. It's also now on Wekeo for the MDB task team. And it comes with Jabber, which is a framework for to massively process the data and improve the processing time of the MDB production. So we are also involved in future ultra-high resolution missions. So in particular, we are supporting TNES in Trishna mission. So Emmanuel Autrey is a co-PI for the coastal waters, and she's doing the liaison with the user community. In the meantime, so waiting for the launch of Trishna end of next year, we are working on this Calista project, which consists in developing coastal GHRSST datasets based on existing missions like EcoStress and Landsat 9 in order to promote the usage of this new high-resolution data and to foster the user uptake. So there is a poster and there will be also a presentation by Emmanuel tomorrow. So, but the objective is to have like a demonstration data set for some user-defined area covering the European coast, French Polynesia, and Caledonia. It comes also with a virtual research environment for easier collaborative work and usage of the data. You will also have a poster end of this week about this. So we plan a public release of this dataset by next fall. Last, so we are also supporting the validation of in situ data of SST data, so through in situ measurements. So we just purchased an infrared radiometer from NOC, an ISAR. This takes place in the context of the future Trishna mission. So the instrument has been delivered last May. And right now we are clearing the custom issue between Brittany and France. And if it's completed on time, we plan already to like a field campaign where we will deploy the instrument. So southwest of Brittany on a IFREMER research vessel, pourquoi pas. But the idea will be also in the midterm to embed this ISAR on some ferry line, particularly on areas which are not covered for now by the ferry lines, which embeds already an ISAR. Like currently, you have this coverage of the English Channel and the Bay of Biscay. So we would target more like ferry lines along the coastal, the Mediterranean coastal areas. So in summary, so we have a sustained production of all these multi-sensor high resolution L3, L and L3, L4 datasets. Some of them including in Copernicus Marine Service, but we are more and more focusing on ultra high resolution coastal products. So about 60 to 100 meter resolution. So currently from Landsat 9 and EcoStress, and in future in support to the Trishna mission, which is a French-Indian mission. And we are also dedicating a lot of effort in developing shared assets for the validation and improvement of SST through this in situ dataset and support software. Thank you.
Next, we have Steiner Eastwood from the Norwegian Meteorological Institute.
Thank you. So I'm Stanley Risted from the OSSAF team, and I'm here to present our agency report. Here's, I hope, all of the OSSAF team members related to SST, IST, and CIs from Met Norway, Danish Meteorological Institute, Met France, and IFREMER. So for those who don't know, the EUMETSAT Ocean and CIS Satellite Application Facility project, we've been providing operational services in 2002. We are developing, producing, and distributing remote sensing products derived mostly from meteorological satellites and that are describing the ocean surface. So the OSSAF products are CIS surface temperature, sea surface temperature, other CIS parameters as concentration, emissivity, edge type, drift, and icebergs, in addition to wind speed and direction. We have both operational near real-time products and climate data records, in addition to climate indicators. The team at Met France are producing both global and are producing global products, both from geo and polar orbiters. The ongoing evolutions for all the processing chains are changes to a new SST climatology from the European CCI project. Instead of the old in-house one, they are switching to the Copernicus CAMS dust aerosol forecast instead of the present data, and they're also upgrading their ready transfer model version of RTTOF for their ready transfer simulations, which is a part of the SST retrieval. Currently, they are working on the Meteosat third generation SST product, and it's been pre-operational since June last year, and are now more or less ready for operational to be operational by the end of the year. The two figures here are just to show the current validation results for October last year with good results and yeah, low, median error and robust and deviations bias at the top and at the bottom distant deviation, robust deviation. Also, they will replace the current NOAA 20 with NOAA 21 for the WIRS level 13C SST products before the end of the year. And the reprocessing of the MSG Severi archive is ongoing. So the team at the Danish and Norwegian Meteorological Institute, we are working on polar sea surface temperature and ice surface temperature. Our new real-time products are both level 2P and level 3C, currently based on the METOP B and NPP WIRS. This autumn or summer autumn, we are now switching to METOP C and the NOAA 21 WIRS. Also, we are working on the new version of our climate data record for infrared called ASTI version 3, which will be reprocessed back to 1982 with the newest developments, which includes a probabilistic cloud mask from the nowcasting South PPS, including a ice mask as well, and also switching to a one-range IST algorithm. For more details, please come and see our poster on ASTI, which Vibke is presenting. I would also like to mention an upcoming new set of products from OSSAF, which will include a passive microwave surface temperature product. Also important for many of you SST producers are CIS products, so I'll give a few slides on that. We are producing global products for CIS concentration, drift, type, MFC, edge, and icebergs, both near real-time and climate products, in addition to climate indicators. So last year we had an important event that we more or less stopped using the SSMIS sensor, since it's now becoming more unreliable. And our main sensor is now AMSER 2. We are preparing for the switch of AMSER 2 to AMSER 3. We'll hear more from JAXA tomorrow about the status of AMSER 3. And we are fortunate to get products or data, test data, so that we have a processing chain working already for AMSER 3. Yeah, so just an examples of all these CS products. On the left-hand side, you see our climate data record starting. You see here examples from 17th of June back to 1979 to present, and also CIS extent here as a climate indicator for all the years back to 1978. Yes, that was it. Thank you for your attention.
That concludes our session. We have actually 5 minutes if you wanted to ask questions about the last 3 talks at this very time. Any questions? Okay, we're done for now. Okay, Chris?
I had a question for Jeff. Where is he? It's about your prototype analysis using Landsat in the coastal zones, which sounds quite ambitious. Since there's a few minutes, could you tell us a bit more about what you're actually trying to do there?
Okay, so if you want to talk in detail about this, so there will be I have a poster this afternoon, and also we have a presentation of Emmanuel tomorrow. But the idea is really to try. There is no currently systematic SST products for Landsat, so the idea is to try to bridge this gap in order to provide demonstration products to the users that are representative, at least in terms of resolution, if not quality, of what you can get with future Trishna, LSTM, and Eagle missions. So we have trying to design this full processing chain, so including all the denoising, SST calculation, cloud masking, and so on, to deliver the best quality we can achieve for this data set over specific area, but also as an open source toolbox so that people can apply the same processing to other area of interest if they collect the input radiance data from the USGS website.
Okay, thank you. Are there any other questions for the 3 talks we just heard? Anyone online?
I have another question for you, Jean-François, on your system. The GHRSST, the distributed computing, could you describe in a nutshell, I guess 3 things, what it is, and I'm interested in scalability, open sourcing, and the cost to run this system?
Okay, so
I guess that's a lot. Maybe I already have a poster on this, but maybe say a few words on that, please.
Okay, so yes, it's designed for embarrassingly parallel processing. So meaning you have the same processing that you want to apply to thousands of files or inputs, and it's meant to be deployed on different architectures, so different infrastructure and cloud infrastructure, and it's full Python, and it's open source. So we are building different connectors for different types of infrastructures. So we do not cover probably all of them, but we cover like a PBS, HT Condor, a Slurm-based processing system. And it comes with some monitoring tools and so on to follow the status of your processing, and we repeat failed jobs and stuff like this.
And do you provide any potential users, like a sandbox, to try out some processing, or is that not part? of
No,
your
it's
architecture?
it's deployed on private infrastructure for now, but as I said, except for the WKO infrastructure, which is public. But for now, we only provide the framework, the source code to deploy it yourself.
Okay, thank you.
One more question here.
I'm sorry. A question also for Jean-Francois. With the focus on higher resolution missions, Trishna and other missions that are coming up, you know, one of the data sets that I think is so important for validation of high resolution is sail drone. Are there any plans to support more sail drone missions as these remote sensing and satellite missions such as Trishna, you know, come online? Thank you.
No, I'm not aware so far of using sail drones for Trishna validation. For now, it's mostly based on in situ radiometers, both for calibration and also for SST validation later. But anyway, we are missing a lot of measurements in any coastal area. So I guess any source of measurements that would become available and would be greatly valuable for the validation in these areas.
Thank you.
Okay, if there are no more questions at this time, then I'd like to dismiss us for lunch, and we'll be back to start our session at 2:00. Thank you.
Welcome back from lunch, and we'll have the second session of agency reports. Myself and Shaquila are your moderators and rapporteur, but I'm going to give a talk right now, and I'm going to just give a brief report on what we've been doing in the NASA PODAC over the last 12 months since the last time we met. And I'm Ed Armstrong, for those who don't know me, longtime member of the GHRSST science team, and I work in the Physical Oceanography DAC, which is one of the 12 NASA data centers for Earth science for oceanography. Okay, yeah, and I apologize. These slides are a little bit short and dry. I did have some nice prose in the written document that I tried to translate over into the slides in the last hour. Okay, so just a quick overview of the Physical Oceanography DAC. We're one of the primary conduits and the distribution nodes for GHRSST data. We archive and distribute over 100 GHRSST data sets. Some of the new stuff we've released, probably you don't know about, but the Sport Level 4, the NASA Sport Level 4 data set produced by the Marshall Space Flight Center has been available since about 7 or 8 months. It's novel in that it's actually produced twice a day, so it's both daytime and nighttime. I don't think there's a GHRSST Level 4 data set that's like that yet. And also, we've haven't quite released yet. We fully ingested and documented the GOES 19 SST products from NOAA. So probably this week we'll send out public announcement. Those data sets are discoverable and usable right now in NASA Earth Data Cloud. And of course, you know, our charter is to continue this support a growing global user community, and I'll document some of the things we've done along those lines. Just quickly, some user metrics of the last year. You know, nearly on an annual basis, 2,500 unique users, 1.2 petabytes distributed. So, you know, something on the order of like tens of terabytes, 100 terabyte a month, and 117 million files distributed. Compared to last year, kind of really not that much change, just kind of slow, you know, steady, the same kind of commitments from users. And where did that, okay, little technical difficulty, sir. Anything that I did? I don't think so. There we go. All right, one of the big topics that we been working on, I've talked about this the last 2 cycles at these meetings, is this area of cloud data virtualization. And this is where we're applying these new aggregation technologies, KRChunk plus Virtualizar, and this new one called IceChunk, to essentially aggregate the entire time series of NetCDF data files so it appears like one collection. And it really helps you both in and out of the cloud to do scientific analysis without downloading the entire data set, just working with those bits of the time of the global time series that you're interested in. So we have 13 data sets that have been virtualized using KRChunk. That's a more mature approach. IceChunk is the new kind of kid on the block that does a lot of cool things like data versioning and allows you to do appending, which you can't do elegantly with the KRChunk model. And so we've done 2 data sets virtualized with KRChunk. So out of this collection, 4 GHRSST data sets have been virtualized, and you'll see what they are right there, including Ostia, Muir, Muir-25, and the level 3 super collated from NOAA. And then one of the latest things that we've been working on is we have built this infrastructure, and come to my presentation on Thursday. We'll take a little deeper dive in this, but we have an infrastructure that we're expanding operationally to do weekly updates on select data sets. And one of the things, so this technology lends itself very well to level 3 gridded data sets, of course. We found a way with what we call well-behaved level 2 data sets to do aggregation of those data sets. And we have actually some working examples of those. Unfortunately, not SST. We found some problems with like MODIS and the remote sensing system are AMSR2, but if the data set is well behaved, and I'll talk a little bit more about that in my presentation on Thursday, we can apply this technology. All right, some of the community outreach we've done, and we're working the standards. We've actually conducted a NASA Earth Data webinar on cloud data optimization. That was last August in 2025. And we are participating in the STAC and ZAR3 best practices review that's being coordinated by the NASA ESDA Standards Coordination Office that I'm a member of. We've also been contributing to CIOS. We've been contributing to the CSRD surface temperature specification planning. I think we'll discuss a little bit more about that in Thursday breakout on the GDS3. And we provide representation, of course, on the CIOS, SSTVC, and COAST VC, and supported the various different GHRSST task activities, including in comparison, CDAV, and GDS. With regards to what products we produce operationally, that of course that's the Muir and Muir-25 level 4 SST products. I've actually taken ownership of the Muir data production since about the last 2 years. And we also produce L2P from the Modus Aquaterra and the SNPP VIIRS. So we actually have code to produce SST for the N20 VIIRS as well that we haven't implemented, but it's already been reviewed and tested. And we'll be rolling that out within the next few months. All right, just a little more specifics on the Muir production. The current Muir production is still on premise, and we've recently conducted a study and to develop a cloud-native pilot system that's been under development, a 1 year with a 1 year funding from NASA. And the goal is to produce operational cloud production of the Muir and the Muir-25, so to run it directly in the cloud. And the motivation of that, because it's currently running on premise, and the directives from NASA is to retire all the on-premise hardware. Most of it should have already been retired, so we need to do that. And see my poster on this subject. We call it the Muir in the Cloud project. All right, my last 2 slides, a little bit I wanted to inform you of some of the things that's going on NASA with regards to organization and logistics and future missions. So the program that I work for in NASA, the Earth Science Data Systems that ESDIS and all these DACs are under, has gone under a reorganization activity. And what's going to happen is there's going to be what's called 5 science enabling teams that are going to replace these 12 NASA DACs. That PODAC is one of the 12. And this is going to occur in 2027. And instead of DACs, they're going to have these spheres, these science enabling teams in specific spheres. And the PODAC is going to transition into the hydrology sphere. So there are going to be other spheres like the biosphere and the cryosphere. I think something atmosphere, maybe one other one, geosphere. But yeah, the PODAC is trying to position itself to lead the hydrology part. So all the water, both the ocean, and of course we have SWOT data now that's used for inland reservoir and reservoir studies. So we're trying to position ourselves to lead this hydrology sphere. So by this time next year, the name PODAC is going to be retired and will be called something else, the hydrology sphere. But from the perspective of the user, it's really going to be, these are all kind of like behind the scenes changes, and there are a number of motivations for that. The impact to the users and data producers is really going to be minimal. It's really kind of like behind the scenes reorganization so that there's a common ingest infrastructure and things of that nature. But the scientific expertise and subject matters, like persons like myself that work with the data producers and the science community, those are going to be remain. So from the perspective of the user community, there's not going to be that much change. It's just for your information. All right, my last slide here is on future NASA missions and also some retirement of some missions. So the surface biology geology mission that has been reconfigured and renamed into the EAGLE mission is actually not a rename, it's a reconfiguration with a hyperspectral component of EAGLE targeted for 2028. So EAGLE stands for the Explorer for Artemis Geology, Lunar and Earth. So you see that NASA has tried to reconfigure and justify some of these Earth science missions that they also have an influence and a capability to do things in other planets, and in this case to observe the moon, to look at things like the topology and the mineral structure. So that's the reason, one of the reasons for the name change, EAGLE, and the thermal part of EAGLE IR that we're really interested in, that had the thermal IR radiometer with 60-meter resolution. That's still in formulation. So when that actually is going to be launched, obviously sometime after 2028, but at least it's still alive. Both, as being funded for the first part of the mission and in concept for the second part. So for the flagship EOSDIS missions like Terra and Aqua, they are coming to an end. Terra Modis is positioned to end around for science operations around the end of February 2027. So no earlier than 2027. It could be a little bit later. Aqua Modis, August 2027, and SS&P VIIR's science operations will end around December 2026. And I think that concludes all I wanted to convey to the audience. I hope you found it useful. Thank you.
Thank you, Ed. Next up, we'll have Pallavi from the Australian Bureau of Geology.
So hi, I'm Pallavi Govika from Bureau of Meteorology, and I'm happy to report our. Yeah. Is it good? Yeah, okay, sorry. I'm Pallavi Govika from Bureau of Meteorology, and I'm happy to report our activity from Australia to Greece here. So I would like to acknowledge my co-authors here. Chris and Paolo work with Satellite SST with me, and Haipeng, who is present in the audience here, looks after SHIP SST and other in-situ SSTs. So the Bureau of Meteorology through the IMOS project produce a wide range of level 2, level 3 and level 4 products from AVHRR, VIAS and Himawari sensors over the Australian region going back to 1992. Australian agencies and IMOS also contribute in situ SST observations from ships, Argo, plots, drifting buoys, and Southern Ocean flux mooring. These in situ SST data are important for satellite SST CalVal and ingestion into SST analysis. So during last year, we basically worked on improving our bias model for Himawari 9. So this Himawari 9, we are retrieving with University of Reading SST CCI version 3 code that includes Bayesian cloud detection and radio to transfer RTO 13.2. And we reprocess all data for Himawari 9 going back to 1st October 2022. And then we use these L2Ps from Himawari to produce L3C and then geopolar multisensor, that is combination of geostationary Himawari and then polar orbiters AVHRR and VS. The bias model that we developed for Himawari 9, we are now collaborating with ISRO to use that same model to insert 3D, and Neeraj will be telling about that on Thursday. So all of our products are available through the NCI. So NCI is the National Computing Infrastructure in Australia. They provide us thread server to make the data public. So it's available, all the data is available through them, and also through IMOS. There is an Australian Ocean Data Network. So through them also, most of the GRIS products that we produce are available for public. The right-hand side panel here is showing our work with different satellites, and then how we improved from Himawari 8 to Himawari 9. So for Himawari 8, we use earlier version of RTTO. The Bayesian cloud detection wasn't tuned with Bureau's NWP. So all that work was fixed with Himawari 9, and the upper panel, orange to red. Orange is the Himawari 8 and the improvement. So now Himawari 9 is comparable to other satellite sensors. So that all things are coming up together. For the level 4, we have Delhi Foundation SST analysis, RAMSA and GAMSA. They ingest satellite data from AVHRR, VS, and MSAR2 at the moment, and in situ from ships, drifting buoys, and moorings. And the plot there showing the robust standard deviation of L4 minus GAMSA. This plot is I have taken from SQUAM website, and it's showing GAMSA has agreed closely with CMC, geopolar blending, and Ostia. So these level 4 SSTs, GAMSA is being used as Bureau's numerical weather prediction models, initial conditions, and for seasonal forecasting. So the another thing, the downstream application, last year we worked with OSTEM. So this is a marine heat stress and marine heat wave monitoring tools. We are using the level 3 geopolar multisensor and stars climatology. And AODN had made this product real time. So all the daily NetCDF files are available to public. And also from AODM, IMOS Live was introduced. So that is the display tool for all the IMOS products. So satellite product and in situ products will be available in at one place, and users can go historically back. So for SST, they can click on any pixel and they can go back to 1992 time series. So that's all sort of things are now becoming available, and I will be talking more on this in my presentation tomorrow. The goal of the IMOS Chip SST Sensors project is to improve quality, quantity, and timeliness of ship SST data in the Australian region. So from 2008 through IMOS, 28 ships have reported quality controlled real-time SST depth to the GTS, IQAM, and AODN. And you can see in the top map their cruise tracks over the past 17 years from IMOS, and currently 11 ships report real-time quality control data. So the plot down there is showing NOAA's IQAM website from and it is showing a robust standard deviation of in situ SST minus CMC SST analysis, and IMOS has contributed ship SST depth data at greater accuracy than most of other ship observations available with GTS. In 2014, ISAR SST skin products became available, and these are the radiometer giving the skin SST, and the last year CSRO received a new ISA sensor, and it is becoming operational on RV Investigator, providing good quality data. So over the coming years, we are aiming to get our Himawari 9 in operations. We will be working with ISRO to get bias model right for INSAT 3D. We are aiming to enhance our OSTEM, that marine heat wave metrics, tune more to biological world. And for the IMOS ship SST, we will be having more newly recruited IMOS vessels equipped with ship AWS, and reprocess ISAR skin SST data from 2026 voyages. And I think that's it from me. Thank you.
Thank you, Pallavi. Next, we have Niraj Agarwal from the Space Application Center, ISRO.
Very good afternoon. I'm Neeraj Agarwal from the Space Application Center, ISRO, India. And I would like to acknowledge my colleagues here, Jashad, Tej, Rishi, and Pradeep, are part of this SST working group there at ISRO. So I'm going to present the ISRO agency report. So these are the highlights. So we have 2 geostationary satellites in orbit, 3DR since 2016 and 3DS since February 2024. So 3DS imager has improved radiometric quality due to improvements in the spacecraft to mitigate the issues related to the black body calibration and midnight sun intrusion. So 3DR, we had some problems because of the black body calibration and other reasons, but 3DS has mitigated these problems. Then another mission, OceanSat 3A, which is a follow-on of OceanSat 3, will carry sea surface temperature monitor instrument. Actually, it was planned to be launched in 2025 December, but somehow still delayed, and we expect this to be launched sometime in the 3rd quarter of this year. So it will be having a split window thermal infrared instrument with a spatial resolution of 1 kilometer. Then the joint ISRO-SINUS Trishna mission, the SST algorithm document has been finalized, and it is validated based on eco-stress data. Then in future, we are planning to move on to the 4th generation of INSAT series, and the system design and instrument specifications have been under discussion, and the satellite, basically these specifications are being discussed with various operational agencies and the stakeholders. Then we are also working on bulk SST retrieval algorithm for InSat 3DS. Another effort that we are doing in collaboration with the Bureau of Meteorology Australia is to make this InSat 3DS data available in GHRSST format. So we are thankful to the Bureau of Meteorology. They are helping us in this effort. For the InSat 3DS, we have also done the G6 bias correction to the L1B data sets. And since September 2025, this is operational, and the prior data will be reprocessed soon. So this is regarding InSat 3DS. So it was launched in February 2024. It has a 6-channel imager, and it has a basically TIR1 and TIR2 bands are there along with the MIR channel. So the two bands, TIR1 and TIR2, are used for SST retrieval, and we get 30-minute and daily average products. And so, as I mentioned, the black body calibration is improved, and we have a better radiometric quality. And the efforts are going on to make this data GHRSST compliant. So there will be a poster regarding the validation status in the second session of the posters. So there the details will be presented. So regarding Trishna, so the nonlinear SST-based algorithm is developed, and the algorithm document is prepared. And an initial assessment of the retrieved SST from EcoStrat observations shows an root mean square error of 0.8 K on 3 water bodies in Lake Tahoe, Salton Sea, and Constance Lake. So this is one representative sample of the retrieved SST using the EcoStress data. And so the ATBT is finalized. And the potential applications which we are looking from Trishna are to basically see the thermal gradients near the lagoons, coral lagoons, and the discharge from various estuaries and nuclear power stations in the ocean, which are not captured by the current SST products. So these are the future satellites. OceanSat 3A, we hope that it is going to come in 2026, third quarter, which will be having a SSTM. And in addition to the scatterometer and the ocean color monitor and a millimeter wave atmospheric temperature and humidity sounder. And the fourth generation, which is under plan, will be having an advanced imager for SST, and other applications. And additionally, it will be having a lightning mapper and hyperspectral sounder. So these are some of the applications that we have been working on continuously. We are making use of a lot of GHRSST products to develop these kind of applications, and then we are transferring these applications to the operational agencies in India, primarily the potential fisheries zones, then marine heat waves, and then we are also doing some sort of research in process understanding at the submesoscales. So I just wanted to give you this status of the NISAR, which was launched last year in July. It was a joint NASA-ISRO synthetic aperture radar mission. Of course, nothing to do with sea surface temperature, but it's a unique mission having two synthetic aperture radar, one operating in the L band and the other one in the S band, used for various applications, mainly over land, but also over the oceans. It can detect the internal waves and oil spills. So the data is now coming from this satellite, and hopefully it will be made operational in August. So in India, the satellite basically is, the requirement of the satellite is demand driven. Basically, we have the users, they fund for the satellites based on their demands, and then we go for a mission. So there was a big meeting last year in October where we had a brainstorming with the various operational ministries which make use of the satellite data. And there was a lot of brainstorming in what sort of requirements are there for what are the gap areas in the current missions. And we came out with a list of or wish list of the future missions that we would like to have. So this is a list, basically OceanSat 4, INSAT 4 generation. So all these missions are there in pipeline in the next 10 to 15 years. So this is our data archival portal. So a lot of users are downloading the data, mainly Indian users, and they're making use of the sea surface temperature data sets from there. And this is basically the timeline of the various missions. The green ones are the ongoing missions, and the yellow ones are the approved missions which are going to come in near future. That's it from my side. Thank you.
Next up, we'll have Shakila Baker from NOAA.
Great, thank you. I'll be brief. So everyone, I'm with NOAA NESDIS, and I wanted to just say we have quite a suite of products that we work with. We have our blended SST product series. Our algorithm lead there is Andy Harris, and we have our AXPO SSTs. Our product algorithm point of contact there is Ali, and we have our Amster SSTs. And our PI on that is Paul Chang. And then we have our OISST, Reynolds OISST we still have going, and that's Boeing. And then we have Veronica Lance, who's working collaboratively with our SST team, Andy and Oliver, on the products. And I just wanted to say Ken Casey, everyone knows, he's working on our data stewardship, and he sends his regards. So NOAA NESDIS contributes to GHRSST community as producers, distributors, and users of SSTs, as you know. And I want to say that one of the things that you get from this message moving forward is that we are doing a lot of reorg, and we are looking at removing the concept of just the OSPO operation name and the STAR name and the NCEI name. And we're all going to be under one umbrella generally. So as we move through this over the next 6 months, we're looking at changing all of our RDAC names to just a general NOAA, as we spoke of earlier. So NOAA's mission in science and service and stewardship, satellite operations and data distribution, and we try to, take in our user input as we continue to evolve. So please do let me know which SSTs are really useful for you, because there's a lot going on and a lot's changing as we move forward. So generally, we have our common cloud framework, which is called our NCCF, and we've been migrating all of our on-premises processing onto a cloud, an AWS cloud, as I've mentioned before. And we are nearly done with that work. We have, again, we have these blended SST, our optimally interpolated SST, Reynolds, and our advanced clear sky processor called AXPO, geostationary physical retrieval. We also do that with the MediaSats. And we have the Amster products that we put out. So I'll just go over those briefly. I'm not advancing. Okay, so the slide is not advancing for some reason. There it goes. Okay. All right, so for blended SST, we have the nighttime only SST, we have the day-night combined SST, and the diurnally corrected day-night SST product. The 3 suite of products are still out there. And for that one, the update we have is that it should be heading into our AWS NCCF cloud. In fact, next month, July, it's been a task. We have, working with us in NOAA, we have our Office of Common Services. So our SSTs that we have, that we process, we don't just go directly from our traditional STAR into primary operations. We're now going with a middleman between. And so we have a large team of people, and it's taking quite a lot of time to get everyone spun up so that this process works more consistently. So it's a process. For the blended SST, so we don't have the GDS update just yet. That'll come next year, as well as the RDEC update. We're going to replace the OSPO in the file name with NOAA. That will come next year. So it's not ready just yet because we had to get a lot migrated, and we're feeling pretty confident with that migration into the cloud, and we'll get it running. And then next year, do expect the OSPO to disappear, and it'll just be NOAA in the file name. For the optimal interpolated SSTs, I think the last update on that about a year and a half ago was including the level 3 supercollated ABHRR as the other ABHRs went offline. And so that product is pretty stable. There's been no new changes in it per se. They will try to get the GDS update implemented next year. And we're trying to, again, replace the NCEI in the file name with NOAA. And there are no algorithm updates. We have at some point in the past been trying to work on a more next-gen SST effort, depending on funding, but maybe more next year. So the AXPO products, the L3U and L2 products, we have those for the VIIRS, S&P, NOAA 20 and 21, the JPSS satellites, as well as the GOES sensors and the HIMARORIs, and then the ABHR MEDOP B and C products. The NCCF version 3.0, we've been waiting for to get it operational in the cloud. It's out there. I think it's been provided preliminarily, and we're about to get that migrated by end of this year. The, again, OSPO and STAR in the file names is to be replaced with NOAA, so we're moving away from those RDAC names and should be just one uniform name moving forward with that. Additional algorithm updates include the VIIRS cloud mask and recalculation of SST retrieval coefficients. And that's for the AXPO 3.0. Let's see. Okay. And then we have the AXPO Clear Sky delayed time products, the RAN products, and there's an additional product suite that's made in delayed time to go back and do some additional checks for quality control. And I think those are all, Ollie has been working on reprocessing all of those back to 2012 to present for the VIIRS ABHR, as well as the MODIS has already been processed, and the GOES ABI and GOES ABI for 1619, as well as the HIMARORI. So the delayed time products are available through our NOAA Coast Watch, has been providing those nicely. And then JPL also provides all of those products. NCEI generally has our NOAA archive of products. So most of those have not migrated over because of the reprocessing, but we're planning to get all of our SSTs into our NCEI archive for availability. Updates expected for the AXPO. I think Ollie has been working on version 3.1, which he has a poster. Please see session 7 and session 6 there, with new and improved water landmass SSC algorithm update based on a feed forward neural network component for that. So he's been doing some work on that. The physical retrieval, I thought we had the L3s. That slide got missed. We also have the supercollated AXPO SSTs. Somehow that slide was missed. That's there as well. And then we have our physical retrieval GHRSSTs from our MediaSat platforms that we provide, and that's a physical retrieval algorithm. We're still working on that one. We have that one migrated into the cloud, and the GDS 3.0 updates are expected. This should be in production, I think, next month. We've got it in the preliminary stage, and we'll promote it to the full operational stage, actually. It's been operational since 2025, but we had some problems with our CCAP for the cloud, and we had to go back and make some corrections on that with our other team members that are working with us. There are no general updates to the algorithms for that product suite. Then our Amster products. Now, Amster 2, we had some issues with Amster 2 and the issues that we had, I think, starting in January. We've resolved those issues online. So we're looking forward to getting the Amster 3. We'll be migrating from the Amster 2 to Amster 3. NOAA will not be providing Amster 2 continuously. We'll be making a switch. And so we have a short turnaround time for that, and we are pushing to get the coefficients in place for that currently this month and hoping to get that migrated by August of 2026 for AMSTER-3 moving forward. And the algorithm update there with the general coefficients and additional frequency channels, it will be GDS 3.0. The file name will have NOAA in it instead of OSPO. And our GRIS metadata and L2P updates, we are trying to get those done. Not sure if we'll get those done by end of this year. But we're pushing to get everything all together for AMSTER-3, given the short turnaround time that we have operationally. The long-term stewardship reanalysis facility, we still run that. 1 minute, thank you. Okay, that's still running. We still have the GRIS data sets on that, and we're trying to migrate that into the cloud as well. And hopefully Ken will be able to get that done in April of next year. We have an open information stewardship service system that we're trying to get everything migrated over into, and Ken Casey will be speaking more on that as time moves forward. So generally, looking at agency updates, we also have, some of the slides look like they got removed. We have our JPSS4. There's a slide on JPSS4 coming out next year, September 2027. We're looking forward to that. And then looking also forward to our GeoXO mission that's coming up in 2037, essentially. So that will be all. Yeah, there they are right there. So there's a link there. Feel free to take a look at that. That's coming up in 2027, September. And then our GOZAR series and our GeoXO is coming up in 2032. Those are the two ones that we've got moving forward. Okay, that's all I have. Thank you.
All right, I'll turn it back over to you, Shakila.
Oh, we have a break now, don't we?
We're gonna do two.
One. We're gonna do one more? Okay, all right. So we have Andrea Pisano with CNR Izmir.
Well, good afternoon to everybody. I'm Andrea Pisano, researcher at the Italian National Research Council, CNR, and I'm glad to give you some latest updates and some future perspective for the Sea Surface Temperature Thematic Assembly Center within the Copernicus Marine Service. Let me briefly introduce the Copernicus Marine Service. This is the marine component of the European Union Earth Observation Program. I would say that the Copernicus Service is the largest Earth observation program in Europe. And provides operational, regular, and accurate information for the global and regional ocean through monitoring and forecasting of a huge variety of essential ocean variables covering the blue, white, and green ocean from past to present and future conditions. All data are provided by 8 monitoring and forecasting centers through ocean models. So they provide, let's say, 40 data, and from 8 TAC, thematic assembly centers, that provide 2D information because they essentially rely on observations, both satellite and in situ. And I'm going to talk you a little bit of the SST TAC. So this stack bridges the gap between space agencies and users by providing accurate, regular level 3S and level 4 SST data for the global ocean and the European regional seas. They are provided in both near real time for operational applications and as multi-year data, mainly thought usable for climate application and covering the so-called satellite era. Typically, these data are provides daily nighttime mean maps. However, diurnal products are available for some regions. And typically the spatial resolution range between from 5 to 1 kilometers with the higher resolution for the regional seas. Well, this is the SST catalog at the start of this year. We provide 24 products, 13 near real time and 11 multi-year, plus 2 internal and 12 SST ocean monitoring indicators. Concerning the evolutions, well, this in March 2026, we have reintroduced GIMPI, the Greece Multi-Product Ensemble SST dataset, which represents a valuable tool for intercomparison exercises. Concerning the ingestion of new sensors, we ingested NOAA 21 from VIRS into all products. Between this year and the next one, we plan to ingest AMSR 2 and 3, in practice 3, and MTG. Into all products, particular attention for the ingestion of passive microwave data into the regional products. And in 2027, hopefully SLSTR 3C. These are preliminary results that you will see in the microwave dedicated session in the next days. Well, basically, we decided to ingest passive microwave SST data into small basins because we can increase the spatial coverage, mainly under cloudy condition, with no changes in the statistical properties, for example, in terms of bias and root mean square error. In practice, the impact is small to neutral. We also plan for some of the regional products to introduce 4D VARNet, as Jean-François mentioned before, as an alternative optimal interpolation algorithm. And attention will be dedicated to the exploitation of ultra-resolution coastal data. We are starting by assessing ecostress and Landsat data as preparatory activities for Trishna and LSTM future missions. And yeah, concerning this last point, the ultra-resolution mission, we've been asked from Mercator Ocean to assess ultra-resolution data from 2 private space companies, Aurora Tech and Constellaire, that provide SST data at 200-meter resolution and 30-meter resolution. So this is a good opportunity for us to test, to assess the impact of this data into our data and into our, let's say, algorithms, and to be prepared for the future mission, because we could potentially deliver coastal SST products in the future. Another task we are involved is EDITO, the European Digital Twin of the Ocean. EDITO is, let's say, a platform where marine data and processes, services like an high performance computing infrastructure should be interactive and user oriented. In practice, a user can write its own code and run it on EDITO. And as SST TAC, we are involved to develop an application. This is, I think, my last slides. We are also involved in the C3S production. C3S is the Copernicus Climate Service. University of Reading, Met Office, and DMI are the three production units that produces and develop climate data record and interim climate data record. And these are also available through CMEMS. Hopefully, this management will gradually move from C3S to CMEMS. I think that's all. This is the SST TAC phase. I would say 1/3 of the Greece community is involved in this service. Thank you.
Okay, so I think that's going to conclude for this session, and we're going to hold questions until afterwards. All right? Okay, it's break time.
So we go for coffee break now, and we come back at 15:20. 20 minutes coffee break, okay?
Good, I think.
Welcome back, everyone. We're going to continue with our agency highlights. Our next speaker is Joanna with the Danish Meteorology Institute.
Should I wait? No, I don't wait. So, good afternoon from me. Welcome back from the coffee break. My name is Joanna, and this is the agency report from the Danish Meteorological Institute. We are a huge team of people working on various tasks, directly or indirectly related to GHRSST. So bear with me while I go through. As an agency, we are of course tasked with providing the weather for the state of Denmark. But we also have external funding from EUMETSAT, ESA, and Copernicus for various activities related to retrievals of SST from space and also IST. And most of our funding comes from the satellite application facility of ocean and sea ice from EUMETSAT. We are involved in the Copernicus Marine Service and the Copernicus Climate Change Service. And of course, we have a number of projects with ESA. This is a very short overview of what we do for the Copernicus Marine Service. We are a production unit for the Sea Surface Temperature Thematic Assembly Center that Andrea introduced before the coffee break. And for that, we produce a series of regional products for the Baltic Sea and for the North Sea partially. But we are also part of the Sea Ice Thematic Assembly Center, so the Sea Ice TAC, for which we provide a series of level 4 and level 3S combined sea surface and sea ice surface temperature products for the Arctic Ocean. And those you see on the right-hand side. I'm not going to talk about those very much. And you can see the web address of the Copernicus Marine Service. It's an extensive data catalog. So here also a brief overview for our Baltic SST products. We release 3 near real-time products. 2 of them are level 4. And they are one standard daily product at 0.02 degrees resolution from 2016. And we also have a diurnal product, which is available hourly. So we have 24 of those every day on the same resolution. And that started being produced in 2022. And we also have the corresponding level 3 supercollated product that matches our level 4 product. And then we have 2 multi-year products, 1 level 4 and 1 level 3 supercollated that run from 1982 onwards. They receive annual updates every year, and they are based on ESA CCI and Copernicus C3S reprocessed upstream level 2 and level 3 datasets. And the schematic shows like our processing system. I'm not going to stick to that very long. There is another presentation tomorrow about that. And for the Arctic, as I mentioned, we have 2 actually near real-time products. One has been forgotten, but it's a level 3 supercollated and the corresponding level 4. They are at 0.05 degrees, released daily. And they cover the open water, the marginalized zone, and the sea ice in terms of surface temperatures. And we also have the corresponding multi-year products for those which are also on 0.05 degrees. They also receive annual temporal updates, and currently they are available from 1982 to 2024. 2025 is going to be released later this year. There is obviously a typo in the slide. For the Copernicus Climate Change Service, we released the first combined level 4 sea surface and sea ice surface temperature data record spanning from 1982 to 2021 and receiving regular extensions of interim CDRs from 2022 onwards. Data for 2025 are currently reviewed, and 2026 will catch up by the end of June. The idea is to have monthly updates or running daily updates running on a level T-1, so releasing the day of the month before. There's going to be more about this product as well on a dedicated presentation. Another data set we contribute to the Copernicus Climate Change Service, it's also a combined sea surface temperature and sea ice surface temperature product, but it's level 3. It's only pollard, so north and south of 50 degrees, and it's only based on AMSAR observations. It's the known ASTI dataset. Maybe you've heard that name before today. That's up to 2019, and from 2019 onwards, it's an ICDR, an interim climate data record released from Copernicus funding. And the entire dataset is available on CDS. On the context of OCSAF, there's also sea ice products on level 2 and level 3 that are handled by the Danish Meteorological Institute, but released through the OCSAF, of course. We've got sea ice concentration data and emissivity data sets that are based on microwave observations. And we also have the surface temperatures from AVHRR. And in 2027, there's also going to be surface temperatures from AMSAT-3. That's a product under development. We are also involved in the fiducial reference measurements through the Ships for SST project that's running since 2017. For that, we operate 3 ? Sometimes 2, sometimes 1, ISARs. They are deployed on a ferry called the Smyril line passenger. So it's a Smyril line passenger ferry called Norona that goes from the west coast of Denmark to Iceland. And you can see on the bottom left as you look at, there is the, top left as you look at the slides, there is the route. And there are weekly trips between Denmark, Faroe, and Iceland. So we have a very big data record of those surface retrievals. And on the context of fiducial reference measurements, through the Trusted project, there's also our contribution to the development of fiducial reference measurements ice buoy. It's meant for Copernicus Sentinel-3 validation, but the idea is to estimate the skin temperature from a simple linear technique, and it uses as a reference skin temperature from a thermal infrared radiometer. In 2020, the winter of 2025-26, we had the deployment of the first batch of trusted ice buoys and the data analysis. So it's a prototype that we develop for making reference measurements for sea ice surface temperatures. In the context of SIMR, which is the Copernicus Imaging Microwave Radiometer mission to be launched in 2029 or 30, we are involved in the L2PAD project, where the idea is to develop the retrieval algorithm for the polar regions and the adjacent seas. And also, as a bonus, other scientific data sets we work with. From an ESA perspective, through the PISCO project, we have already developed the polar ice sheet surface temperature climate data record based on satellite data. It's a level 4 data set that covers the Arctic, Greenland and Antarctic ice sheets. And it can be used for model assessment for surface mass balance, for example, or for monitoring the surface temperature and trends of the Greenland and Antarctic ice sheets. And also, again, another is a funded project, Motecosuma. We are working on developing or making the first CDR of 2-meter air temperatures based on satellite surface temperatures. And this is also going to be released at some point this year, or if it's not available yet, and I don't know it. And with that, I would like to thank you for your attention, and I guess questions later. Thanks.
Thank you.
Okay, next up, we have Eri Yoshizawa from JAXA.
So good afternoon, everyone. I'm Eri Yoshizawa from Japan Aerospace Exploration Agency, JAXA, Earth Observation Research Center. Here is my colleagues. And today, I would like to share with you some updates on our agency's activity related to the GLIST community. There are 3 major updates from the last year's meeting. 2 of them are related to a new microwave sensor, AMSA-3, and the remaining one is a new data portal that was available last year. Then I would like to start exploration their details. So this slide shows Japanese Earth observation satellites and sensor with their operation schedules. Currently, 9 Earth observation satellites are operated by JAXA. In addition, Himawari satellites are operated by Japan Meteorological Agency. Among JAXA's satellites, GCOM-C, GCOM-W, and GOSAT-GW are related to SST retrievals. This one is the latest one, equipped with a new microwave sensor, AMSA-3. The GOSAT-GW AMSA-3 was launched on June 29 last year by the H2A launch vehicle number 50 from the Tanegashima Space Center, located on one of the southernmost islands in Japan. Here is a movie of the launch. Yeah, that was one of the most beautiful scenes that I ever had. This vehicle lifted off at midnight, making the satellite to get data on 1:30 p.m. And as you can see, the area as bright as daytime. Maybe this is end of. So after about 60 minutes from the liftoff, the satellite was successfully separated from the vehicle. After that, AMSA-3 began its observation on August 11. This slide shows early observation results from August 15th to 17th. The left panel shows an RGB composite image using 1989 and 166 GHz vertical polarization brightness temperature data to show a performance of a newly added 166 GHz channel. We also confirmed the performance on the early observation of SST. Here is SST global map, SST spatial map in the Pacific side. As you can see, the SST product in August clearly captured anomalous temperature signal propagating zonally in the El Nino and La Nina region. So please refer to Ms. Kachi's presentation on tomorrow morning for details of the AMSA-3 mission and recent results. So after the start of the observation, we have proceeded initial calibration and validation. And finally, AMSA-3 version 1 product are planned for release in late June this month. So here is a list of AMSA-3 standard products. Brightness, temperature, and 11 geophysical products related to atmosphere, ocean, land, and cryosphere research will be released as a standard product. I show you one example of version 1 product. Here is a spatial map of 6 GHz SST global map on June 7th this month. And SST and as well as other ocean products such as sea surface wind will achieve accuracy comparable to AMSA-2 at this release timing. So if you want to know more detail on the validation results of ocean product, please visit my poster today. So at the same timing of the official release of AMSA-3 data, we also start GLIST format AMSA-3 product. Version 1 will be scheduled to be released at end of this month for both near real time and standard product. This one is standard means delayed mode, but with higher accuracy. But there is one important notice. After the start of distribution of AMSA-3 product, near real-time product of AMSA-2 will be terminated at early September this year. So there is also updates on the GMI SST, but this is a small change. And also we are providing SGLI SST, I mean the infrared SST product. On Wednesday morning, Dr. Murakami will present recent results using SGLI SST data. So please visit his presentation. We also distribute Himawari SSTs via P3 system, but there is no update at this time. So the final update is launch of the GLIST portal, new data portal. So as shown in the previous slide, SST product generated by JAXA have been distributed separately via GLIST and Himawari Monitor. So GLIST portal has been developed to centrally manage GDS products by linking JAXA, GLIST, and Himawari servers. So it is now available at this address, so please feel free to visit and explore it. So there are future plans of our agency related to SSD products. So as for the AMSA2 SSD, I already told that. Even after discontinuation of AMSA2 near real-time products, we also continue provision of standard product with delayed mode. So regarding the AMSA3 toward version 2, we are making effort based on the comparison between AMSA2 and AMSA3, as well as ground truth data. And also there is approach to enhance spatial resolution of brightness temperature data. If you want to know more detail on this approach, please visit Dr. Nakata's poster today. So, skip. So last year, in the Himawari monitor, we extended the coverage of level 1 brightness, level 1 Himawari data. And we are now developed to Himawari SSD using this extended data. And also to smoothly connect Himawari SSD and other geostationary data, we also developed to retrieve GHRSST algorithm. So finally, I would like to tell you about, I would like to make an announcement about future operational plans for post-mission phase satellites. So due to budget constraints, we are being asked to reduce the operational cost after Japanese fiscal year 2027. The reduction of operational cost, including the shortening of the operation period, is required for all Earth observation satellites operated by JAXA. So here is an example, the operation plan of GCOM-W AMSA2. So as I mentioned, near real-time distribution of AMSA2 data discontinued in this September. Even after that, it has been decided that on-orbit operation for delayed mode distribution will continue until end of March next year. However, operations beyond that point have not yet been confirmed. So we are making effort to secure at least 3-year overlap between AMSA2 and AMSA3. So, but we also need to explain the purpose of the overlap and the required duration and the potential impact if it cannot be achieved. So you have any input, please contact Mitsukachi or me. So it is my final slide. Thank you.
Thank you so much. Next up, we have Dorina Circel Collin from the Canadian Center of Meteorological and Environmental Prediction.
Okay. Thank you very much. So I'm Dorina Circel Collin. I'm from Environment and Climate Change Canada. And I will present a short report about our GHRSST product. So we have only one GHRSST product that we produced, is the CMC-SST, what you know about as CMC-SST, an L4 product. It's a global analysis using statistical interpolation, and we are also users of different GHRSST products. In this analysis, we use retrievals from AVHRR, VIRS, and AMSR2 produced by Navo Ocean, by NOAA, or remote sensing system for the AMSR2. We also use in situ data coming from GTS and ice concentrations information from our own product, global ice concentration analysis. 2 years ago in Montreal, we presented a new analysis based on a variational method. This analysis was implemented, but only with an experimental status last year in May. So it has already 1 year since it's running in operations, but only with this status, experimental mode. And is not yet distributed, but if somebody is interested, we can make it available. The difference is mainly in the assimilation method, but also the grid changes, is using the same grid as our atmospheric model. A little bit differences in the thinning and also in the bias estimation of the satellite retrievals. The performance of the SST, of CMC SST analysis was similar to what you know for the last years. So compared with OSTIA, we have a slightly larger standard deviation, but our bias, it's somewhere, we are somewhere close to Argo. For our experimental analysis, both the operational and the experimental analysis are similar. It was our intention because CMC analysis is used by all the other operational systems as CMC, so atmospheric and oceanographic systems. So we didn't want to have much change for the users, internal users. As I mentioned before, in our analysis, we use retrievals produced mainly by US-based organizations, so NOAA or Navo Ocean or remote sensing system. And we made some impact studies and we showed that missing one type of data is going to affect the quality of our analysis. So for this, we were asked to put in place a contingency plan and to be able to replace each type of data with similar data but produced outside the United States. So what we did, we implemented an operational feed from IFREMER for AVHRR retrieval produced by OSISAF. We have real-time analysis running in a development account every day, which are using these AVHR retrievals instead of Navo Ocean. We did the same thing for AMSR2. So we tested only AMSR2 from JAXA for 1 month. The results are good. So we are preparing to implement the feed for this data. This is going to help us to move faster to AMSR3. And for VIRS, we don't have other sources because we use VIRS retrieval at global scales, but we have like 2 feeds, one coming from NOAA directly and an additional one coming from EUMETCAST. So just an example about our analysis compared with the same but using OSISAF data, and also the same thing for the analysis where we replace the remote sensing system AMSR2 by JAXA. In both cases, we see that the bias is larger compared with Argo. So maybe we have to take a look in details about this, but if we are gonna lose some data, we will be able to replace fast and without affecting the quality of our analysis. And for the future, we are working in the assimilation of SLSTR data from Sentinel-3A and B. We did some tests, and I presented something last year for SLSTR collection 3. Now we repeated the same experience, but for collection 4. We tested data in all the format included in the actual collection 4. And we plan to implement this data in our analysis, but the new analysis will become operational in the next implementation cycle. So this will be in operation in January 2028. We are working in reprocessing the SST and ICE analysis using this new version starting in 93 to support the ocean global reanalysis. And for sure, we want to go to AMSER free, so we have 2 months to be able to do this, to replace AMSER 2 by AMSER free. Thank you. This is all.
Thank you. So our next talk is going to be online. We're going to have Anne Reed from UMETSAT.
Hi, everybody. I'll just share my screen. I'm having problems sharing it. Evald, is it okay if you share it from the machine there? I can see you've got it uploaded.
Coming up, getting it ready.
Thanks. Thank you. Okay, hello everybody. So my name's Anne Reed from UMETSAT, and today I'll give an overview of our SST activities and contributions to GHRSST. I'm very sorry that I can't be with you this week, and I'd like to just acknowledge my co-authors and also the Aussie staff. Next slide, please. So our main reference sea surface temperature products are those from Copernicus Sentinel-3, SLSTR. So we've been continuing providing reference products from SST, from Sentinel-3A and Sentinel-3B. We've been developing the new collection 4 or day 2 SST. This has now been operationally deployed on the 11th of June for the SST products. We've had pre-operational products of those available for the last 2 years, available on the Copernicus Wikio platform, and feedback continues to be welcome. We're also operationally deploying sea ice surface temperatures, SSTR-IST, on the 25th of June this week. So for Sentinel-3C and D, so the Sentinel-3C launch is now expected in September. We should know the more firm date for the launch this week, and Sentinel-3D launch will be planned for 2 years later. So on the new collection 4 products, we're very much welcoming feedback on those, and if you have any questions or issues, please do let us know. Next slide, please. So some little bit more details on the collection 4. So this is the sea surface temperature day 2. So the main developments and improvements here have been to introduce improvements to the basin cloud detection in coastal zones. So this is with a project with the University of Reading. So now we're improving kind of inland waters and coastal SST in these regions. We're also implementing a new SST depth field. So this is in addition to the SST skin. This is by implementing a new skin effect and diurnal variability model. So there's the 2 products in there. There's the main sea surface temperature, which remains as the SST skin, but you can also use the SST depth. There's also updates to the total uncertainty for both SSTs and the addition of a full nadir grid. So there's both the dual view product and the nadir view product. The new ice surface temperature product has been produced from a couple of projects, Copernicus projects run by UMETSAT with DMI, and these are now being introduced operationally. So Gary will give some more detailed information on this in a presentation later in the week. Next slide, please. Just a couple of comments on our previous version, the collection 3, so the version that's been operational up to the 11th of June. So these continued the reference products. They're very excellent products with low uncertainties, especially for the dual view on nighttime results. We recommend their use for reference purposes. The quality is better than the single view infrared sea surface temperature products. We do continue to investigate any issues arising from the instrument behavior, such as influences and changes in detector temperature. So all of those investigations are ongoing. And just to note that with the collection 4, we're further improving these products, particularly near coasts. Next slide, please. So as you all know, we now have a new Copernicus GHRSST project office. So this has been introduced already this morning, and you've already met Christina and Evald. So UMETSAT is committed to continuing to provide the GPO through Copernicus funding. I'd also like to thank DMI for their GPO coordination for the last 5 years. This was part of the Copernicus Cipher Master project. Yeah, it's excellent that we've had such good GHRSST project office support over the last years. UMETSAT this year have also been happy to support the Copernicus GHRSST Early Career Research Scholarships again. And congratulations to all those in the room that have benefited from this scholarship. Next slide, please. So just an overview of all the launches. So an overview of the past launches there in bold and the ones coming up. So yeah, it's a busy time as it has been for the last few years. So Sentinel-3C is coming up very soon this September, followed by 3D. We're also preparing SST products from SIMA A and B coming up in the years after. And we're also working on the next generation optical Sentinel-3 A and B. I'll comment on that a little bit more. Next slide, please. This is just an overview of all the current operational products in green for SST and IST. So we've now added SLSTR there for the IST products. We also have various products under implementation and under development. Some of these products are produced at UMETSAT headquarters. Others are done in close collaboration with the OSISAF, and others are produced solely by the OSISAF. So we collaborate on all of those products. We're also very interested in the third-party ultra-high resolution SST data for coastal validation. This will be very useful for us for SLSTR coastal validation. Next slide, please. So a small comment on the future products we're working on and missions. So we're working together with ESA to prepare for the SIMA sea surface temperature products. So UMETSAT will deliver the global atmospheric and ocean products, which will include sea surface temperature. We're also working together with ESA on the Sentinel-3 next generation optical mission, the advanced SLSTR or the A SLSTR, with the A and B units planned for around 2035. Next slide, please. That we continue to provide fiducial reference measurements from the Trusted project, and this is from the FRM drifting buoys. So these are all the measurements to date. As Joanna mentioned already today, there's been prototypes for IST FRMs ongoing this year, and the plan is to continue those into more operational deployments into the next years. So validation with Sentinel-3 data using these FRMs is ongoing. but already we can see they're extremely valuable data. And if you're interested, please get in touch. Next slide, please. We'd also like to advertise the new Copernicus CalVal tool or CV tool. So this has been specifically developed for Sentinel-3, SLSTR, SST assessment and validation. So it's already been very valuable over the last year to finely tune and prepare the collection for algorithms. It's very generic, interactive. You can overlay and zoom and really use it for fine-tuning your validation. So Igor's been developing this as part of the CipherMass project. Again, if you're interested, please get in touch. Next slide, please. We're continuing to plan towards harmonization of SST products for both SST and IST, and this includes products, definitions, methods, and algorithms, also together with the Aussie SAF. This really is maximizing the benefit of reference SLSTR and preparing for longer term evolutions. We've also got an offline or ICDR SST project with the University of Reading, focusing on AVHR and SLSTR, and also coordinating with the Aussie SAF. So the idea for this is that we would then incorporate those developments into our non-time critical products. So as an ICDR for SSTR. Next slide, please. Yeah, I won't go through the summary in detail, but just to mention that we continue our reference quality SLSTR products, and we've just evolved those to collection 4 with the operational deployments this month. We're preparing for the Sentinel-3C launch in September, and I won't mention the other points there. Next slide, please. And I'd just like to leave you with this animation because I think it shows it quite nicely. So this is for monthly, over a month for May, the differences between the skin SST and the depth SST for the Nadir View products for SLSTR using the skin effect and the diurnal variability model. So you can really see kind of the nice behavior of the difference between the skin and the depth. And it also helps you to consider which of those products, the skin or the depth, you should be using for your applications. Okay, thank you, that's all.
Thank you, Anne. Next up, we have Christo Whittle from online as well. He's with CSIR.
Christo, are you online? I don't think he is online. No, he's not online. Do we have? Okay, so we might jump.
Okay,
let's move to Isa.
Okay. I don't know. So no one else is online to give his talk. Is that correct? Okay. All right. So that's the last of our talks. I think that's the last one. So we'll move into the discussion, question and answer session.
Isa reporting. Craig is online. Craig Donlon.
Oh, yes, Craig. Okay, fantastic.
Yeah? Okay.
So Craig is. Thank you. Sorry. So European Space Agency, we have Craig Donlon.
Yes, good morning. Can you hear me?
Yes, we can, Craig.
Good morning,
Please.
everybody. Hopefully this will work. Okay, there we go. So sorry not to be with you, but it was not possible this time for a variety of reasons. Okay, just a very short report from European Space Agency. There's a lot going on at the moment. I'll just touch a little bit on the Sentinel-3C launch, Sentinel-3 Next Gen, a little bit on LSTM, the Copernicus Land Surface Temperature Mission, and the Imaging Microwave Radiometer mentioned by Anne. So, okay, for Sentinel-3, we have 4 satellites, 2 are in orbit now, and we're just about to launch Sentinel-3C. Gives us a lot of measurements over a long period of time. Fred Wimmer and people have published quite a nice little paper using shipborne radiometer data from the SST shipborne radiometer network. You can see here over the 2018 to 2024 period, there's some pretty impressive results. So this is a very stable instrument, SLSTR, very good instrument and very worthy of reference radiometer. For Sentinel-3C and D, there are 2 satellites that are out of storage now for some time. 3C will launch on a Vega in mid-September, together with the FLEX mission, which is looking at photosynthesis from space. It's a new kind of measurement, so that'll be interesting. All the D storage is complete. The SLSTRD is now mounted on the Sentinel-3C. So you will get confused when it goes Sentinel-3C, but we've got the SLSTRD unit. Just bear that in mind. We're expecting at the end of this month that the shipment will go via ship to Kourou, and we'll carry on testing and storing Sentinel-3D. So in terms of the commissioning, it's pretty standard compared to what we've done before, except that we've got a tandem, a dual tandem in there. So there'll be 2 tandems. The first tandem with C and B will take about 2 months, and that will take place towards the end of the phase E1, towards the end of commissioning, and with an expected in-orbit commissioning review at launch plus 6 months. And the second tandem will fly Sentinel-3C with Sentinel-3A. So we'll have the whole set of missions linked up. And I can't remember, so Anne, don't kill me if this is not the most up-to-date. This is what we did last time I had a presentation on this with Umitsat and Jérôme. So it gives you a brief overview of what's going on. So there's a lot of work to be done in the first couple of months to commission SLSTR. And then the important part is we'll have these little drift orbits at about launch plus 5, where we start to move away from 3A and B. And here we'll do some work with SLSTRC and SLSTRB, and likewise with the A and the C down here. And these drift gives us a chance to get the nadir view inside the forward view of the other satellite, which is quite important. It'll be quite interesting to do that. For the next generation, we're looking at enhanced continuity. So these are the missions that will come after this bout of SLSTRs, so ASLSTRs, it's called the Advanced SLSTR. And the idea is to maintain continuity together with the Ultra. Now, we have a separate satellite for the optical instrumentation compared to the topography. And this will give us ocean, land, and atmospheric measurements pretty much the same as before. And we don't have very many changes to the ASLSTR fundamental design philosophy. So, low noise detectors, 2 calibration black bodies, dual view. But we do actually have additional key requirements. So we'll try to go for a resolution of less than 500 meters. We will be looking at additional channels, which are TBD here. I think we're still in negotiation. But these will be at 870, 1.24 nanometers in particular. And that's because the 8.7 channel has been shown to give quite good impact on the retrievals, particularly in the daytime. So that's going to be something quite nice. We did look at a possibility of having a 4.05 micron channel, but was tested, but the impact in this case was considered negligible and was not included. But you will have a super instrument on board this spacecraft covering the visible all the way through to the long-wave infrared. And we're going to be making products this time, since nobody was capable of doing it themselves last time, which come out for this entire suite of channels, so that they'll be very easy to use. And just bear in mind that the ALCHI, the ocean color instrument, will be 150 meters. So cloud clearing at the 500 meter resolution long wave infrared should be quite good. For LSTM, this is a mission that's looking at infrared observations over land and coastal regions in support of agriculture management services. And they're looking at water productivity more than anything else. It's a whispering concept. I'll picture the satellite here. But it does carry some nice infrared channels. This is the fundamental characteristics of the spacecraft. There'll be 50 meters resolution. 1 to 3 days revisit with some pretty reasonable accuracy over land, remember, 1 to 1.5K for them because the emissivity is a challenge. The NEDT on the signal will be about it should be less than 0.15 Kelvin. These are the visible shortwave and thermal infrared channels. So there's a nice suite of channels here. It's a whisk broom concept. So this is the sort of instantaneous field of view from the detectors. So this is actually going to be quite nice. And the acquisition plan covers pretty much all of the same areas of Sentinel-2. So there'll be an awful lot of SST available data. For example, if you look around Europe here, there's a lot, and all the coastal zones of the Americas, these big swaths here. So quite nice. SIMA, this is responding to the EU Arctic policy and is looking at sea surface temperature, salinity, wind vectors over the ocean, sea ice thickness, soil moisture, snow, etc. It's a microwave scanning radiometer. I'm not sure how quick the animation will show, but you can see here it's quite important to note how we sample. We're quite different than other missions. I'll just try and stop it here. And you can see here, there are in the red, we have high frequency channels. So we have 8 feed horns measuring in one scan, 4 C and X band feeds. And this is how we can slow down the scan rate of this big 8-meter rotating mesh reflector, which is coming on pretty well now. Oops, I'll just carry on that animation. And you can see there's one other thing for the L-band sensor. This is looking at a lower observation zenith angle. So the swath is slightly narrower, but the performances are much, much better. And you can see that here. The L-band is slightly lower observation zenith angle than the rest of the channels. But I think we'll be able to deal with that. Performances are here. I'm not going to go through them. Just to say the NEDT at the moment is pretty good. It's been held. So this is what we expect. 0.3 Kelvin in L, 0.2 Kelvin in C and X band, in C band, 0.3 in X band. At CDR, these are still maintained. So we're looking quite good. There is a companion concept being discussed. We have 2 big studies being kicked off shortly, all being well. And this is to fly a smaller spacecraft with a small radiometer. There's a conical scanner here, but it doesn't necessarily have to be that. And the idea here is that we'll get higher frequency, sort of 50 gigahertz and above measurements that we can sound in the atmosphere as low as possible into the troposphere, and then using lapse rates, try to compute the air temperature and humidity above the ocean surface. And by combining that with SIMA's data, we should be able to actually have a direct retrieval of ocean surface fluxes, which should be pretty good. So that's just starting, and all being well, if that proceeds as we hope, then we should have this smaller satellite on orbit within a couple of years of the first SIMA launch, which would be expected in 2029-30. Final slide for me, that we have a big meeting at STEC, 28th and 30th of September, which is looking at new challenges for 2040 to 2060. I encourage you to register. Just search for Earth Observation Architectural Challenges, and you can register there. And this is where we're trying to pilot what we need to do in the future at the European Space Agency for Earth observation and oceans. Thank you very much.
Thank you, Craig. Okay, that concludes our talks, and now we'll move into our 10-minute discussion question session. So were there any questions for the talks that were presented?
Hi, guys. All done.
Thanks, Craig. Were there any questions? Okay. Microphone. I'll give her this one. Go ahead.
There you go. Uh, um, Parvi, I have a quick question, not necessarily slightly, well, fairly related, but you were showing a graph where you were looking at the biases and the standard deviations. In April 2004, there was a huge spike in all of the satellites that increased the bias and increased the standard deviation. What happened in 2004, April? It only lasted for about a month.
Yeah, was that in situ SST product?
Might have been, I'm not sure.
Because the satellite SST that I showed, that just showed April 22 to 25. I didn't show the 2004. So.
Okay,
No.
we'll talk later.
Oh, okay.
We'll go back through and have a look at your slides and I'll show you what I'm talking about. It's just a curiosity, nothing more.
I would like to ask to add some additional information on the future of the SBG that you said that was reconfigured in a hyperspectral mission. So if you can give us some additional information, because as you know, we are interested to high resolution SST. And then Italy was also involved with SDG in general.
I'm probably not the best person to address this because I don't work actually directly with this new Eagle program. But from my understanding is that the configuration of the instrument will be the same, right, with regards to the bands, the number of bands, and all the resolution and swath characteristics and revisit characteristics. They're not going to change anything fundamentally in instrument design. It's really too late. They've already spent like nearly 10 years on this project, right? So I feel pretty confident in saying that Eagle is just essentially a renaming of the surface biology geology mission, and what you've expected it to be is what it will be. But I will say that, as I pointed out in my presentation, the first thing they're going to do is the hyperspectral part, right? Which is the visible and the near IR. That's not really, I mean, yeah, it might be of interest to us, but you can't generate SST from those bands. When will the other Eagle 2 be launched? I don't really have an answer for that. We're looking for 2028 for the first part of the mission, the hyperspectral. Sometime after that, I would say at least 2 years. There's certainly new requirements that these missions have to adhere to with regards to budget. They can't exceed, I think 300 million is the number that they have to budget for. So there are strict budgeting requirements. Sorry, I don't have a better answer for you.
No, but
if you want, I can put you in touch with somebody like Simon Hook from JPL who has a lot more information. He's the
I may be able to provide a little more information. The Simon Hook and the JPL team had a webinar about a month ago that I attended, and Simon said that headquarters told them they had to have exactly the same satellite bus for both the vSphere and the TIR instrument. And so now it's a completely different bus from what was planned originally. So the ASI component apparently has disappeared, which doesn't make any sense, but apparently it's now a Boeing or some American vendor that's going to build the bus that the two instruments will reside on. And this is supposed to save money by having exactly the same platform for the two separate instruments. And the bus has not yet been fully specified, and so it's all pretty unclear, but the idea was because of all the crazy budget cuts going on, this was supposed to save money somehow, And somehow by renaming it, it became palatable to the administration, whereas previously it wasn't, because they cut the entire mission initially, and now it's resurrected as Eagle. So I think the webinar is online. I'll try to find you the link so you can see what Simon Hook had to say.
Thank you for that, David. Yeah, I didn't see that webinar, but I think that would be the first resource to look at that webinar from Simon Hook from JPL.
Were there any additional questions? Please say the question you're directing it to. Andy Harris.
Thanks. Is Anne still online?
Anne, are you still online? Anne Reed?
Yes, I'm here.
You mentioned, or at least you had on the slide, that you were doing FCI as operational processing. How well do you think that's going?
So the FCI products are produced by the Aussie SAF. So at the moment, there are pre-operational products available. And then over the course of the next few weeks, months, they will be assessed if they're ready for operational release.
Okay, because it's actually green on your slide, but
well, they've been pre-operationally
is
available
it the
for
double,
about
I
a
see
year.
the double
Yeah.
asterisk means that it's being done by them. Okay, so you don't actually have a hard number right now.
Not until it's gone through the final evaluation over the next few weeks. I don't know if
Okay.
Steiner has any more, anything more to add.
Okay, thanks.
Sorry, could you pass the microphone?
The FCI product is available as pre-operational?
It's really how well it's going, the accuracy of the instrument, and how well it's validating.
You mean the high latitude, the high resolution?
I just really mean how well's FCI going compared to Severi.
Yeah, that's the two figures I showed in my presentation for stuff, and they look good. But for details, Stefan Sopikar.
Okay, so I could look at yours then.
Yeah.
I'll look at your presentation instead.
Please do.
The strike problem is being solved slowly. So it's going better and better.
Are there any questions online? Okay, we're all done with questions. Turning it back over to our project office. Thank you.
A question for you, Shaquila. So on the whole renaming of the RDACs, the file names, are you going to actually reprocess the entire time series for those data sets? Or is it just forward stream? Because you're going to confuse your users.
Well, that's a good point. And we've been trying to make sure that we maintain our GHRSST metadata and our GHRSST formats with all the changes that we're facing in the reorg and budget cuts and all of those changes. I have stressed that, you know, we have a lot of users, especially our GHRSST products. We've already, I think, started for the 3.0 Expo that already has the name NOAA in it. So I think there were some users of that preliminary release that was put out. That one already has the name NOAA in it. It no longer has that OSPO one. But yes, the OSPO STAR and NCEI, I've reported this in 2 previous GHRSST meetings. So it's not new information in that regard, but we are definitely looking forward to having our names, file name changes. We're looking across NOAA, in fact, on updating file names, and I'm honestly have been fighting to keep all of our GHRSST file name conventions. So staying in line with this new RDAC NOAA is going to help unify all of our products. Again, we are moving away from being an organization in NES called STAR, OSPO, and NCEI. Those names are also going to be removed at some point. So this is in line with the mission of NOAA. And we will work to try to keep our users informed in advance. So I've said, like again, it's not new information in general. I've said it
3 meetings for that reason as we move forward. So perhaps next year, if you have issues with that, send me an email. I can go to people with user feedback. And if you're like, I need 6 months, operationally, I can hold it up if necessary and accommodate you so that you can switch over and make the changes that are needed.
I just have one comment on that. I mean, you're changing the file name too, but one of the defining attributes of a new product is the short name. And so that little short name is going to change too because it has the RDAC name. So technically, I think you need to consider a whole new set of products. Something to think about.
Thanks for the comments on that, but I guess it is a forward change. So all products will not necessarily be reprocessed. There are some components that get reprocessed. I don't know if our Reynolds OISST will get reprocessed because we have been looking at replacing that one with new efforts. These are questions that will be addressed, but I will take that comment back. Thank you.
I have a question for Dorina. Yes. So I'm interested in your CMC reprocessing project, which is great news because I think is it 9 years earlier than currently? Anyway, what are the inputs in the 1990s that you're going to use for that reprocessing?
Yes, this is a good question. So we are looking at different data sets. So for the AVHRR, we're looking at NOAA products, but also we are looking at the products in ESA CCR 2.1, I think. We are not decided yet which one we are going to use, but we want to use AVHRR and also ATSR and AATSR.
There is a version 3 of ESA CCI, which I would recommend compared to 2.1 for the AVHRRs.
Thank you very much.
So this is a question for Haxa. I think in your presentation, your commentary, that now you are working to decide the overlapping period between MCEL2 and MCEL3. So I conclude that it's not decided. You have, I mean, the years, I mean, you are pushing for 3 years overlap period between MCEL2 and MCEL3. Can you provide more information on that?
Okay, yeah. I think at present, nothing decided. Yeah, our original plan is continue the MCEL2 as long as possible. However, the current budget situation is quite worse in JAXA side. And our fiscal year starting from April. So the next April, the budget for the next April is currently, we just send a request to the government, and then decision will make maybe autumn this year. So, and when the budget decided, so we can coordinate or negotiate within JAXA and how much the fund, the budget can be used for our post-mission satellite. So as the early said, is the but for the decision in the autumn, and we need kind of the confident or the proof for the how long the post-mission phase satellite should continue its operation. And it's the continuation is based on the user's requirement or user's preparation for the next follow-on mission. So I think that's because we asked you to if what the kind of the problem may happen in your system if MCEL2 cannot continue maybe only by March next year. So what will happen? So that's kind of the housing input, and also the request from user is quite welcome. I also did talk with the community, like a CIS community or the atmospheric community, asking such kind of things. And if the SST community, of course, this SST community also including the CIS community. So if you have any request for in your system, the institute or your community, so that would quite be welcome to JAXA. Then it's only not covering the AMSI2, but also for the SGLI. So SGLI has a 250-meter spatial resolution, but I know that it's not much used currently in the GHRSST community. But this the SST the product is quite useful for the transition or the synergy with the ultra high resolution sea surface temperature in which will be launched very soon. So I think that the GHRSST community may also interested in SGLI as well as AMSA2. So that's our request. Yep.
May I follow up on that? I think this is an important request to GHRSST users, certainly from the point of view of people that are interested in reprocessing and climate data records. At least a full year of overlap of publicly available data is extremely valuable, and your request for 3 years would be fantastic. So I'm sure there'll be people that will want to support you there. And I think you're right about SGLI and how this is could be a bridge to look forward to the ultra high resolution. And we probably have underexploited that, and let's start to speak to David about that as well, actually. but Masako-san, do you have a date by which you need our comments?
Yeah, I think as soon as possible. No, but yes, but I said that until this summer, I think, yeah, it's better, yeah.
Okay, can we have one last round of applause for all of our speakers today?
We are really on time. That's nice. Congrats to everyone for doing that. So we move forward now. I would ask all the poster presenters if they can. I mean, we are going to proceed as in Copenhagen last year. For those that you were not there, I would like to ask for the poster pitch now before we go for the poster. So I would ask you to just line up there in order. If you remember your poster number, so we will just project the presentations, and you have like 1 minute, 2 minutes for your poster pitch before we just begin the poster session officially. Okay? So where are the posters presenters? Stand up, please. Nice. So just put line there, like in the same order as your poster. Just ask for your. So number 1. I don't have the list. Who was number 1?
You have. Well,
okay.
It's listed there. I don't know if you managed to see. Sí, pero bueno, está aquí. Gracias. Pero como pantalla completa esta vez. How do I make the screen? How do I make the screen full size? Screen? Yeah. Yes. So
Okay, are we ready? So come on, the first presenter. I'm not going. Yeah, you need to come here. See, maybe it's easier to make the line in the other. Is it fine there, or we move the line there? Yeah. Okay.
My name is Kurihara from Tokyo University of Marine Science and Technology. Now we are reanalyzing answers to sea surface temperature for generating a climate data record. To improve the answer to SST, we developed a noise filter specified to answers data. A remarkable point of the filter is to maintain the spatial resolution as high as possible. This is an important point because the spatial resolution of answers data is not very high. It's about 50 kilometers. Our validation result says that filter improves the answer to SST and the SST front analysis using answers data. So my poster presents an outline of the noise filter and its validation results. Regarding the CDR, it will be presented by Professor Kobashi-san in the tomorrow morning session 1. That's all about me. Thank you. Yeah.
So I'm Eri Yoshizawa from JAXA, and in my poster, I will present validation results of GHRSST GW AMSA 3 version 1 products. This one? Maybe. Maybe, yeah. Yeah, I will share with you validation results of GHRSST GW AMSA 3 Ocean products version 1. For example, sea surface temperature, sea surface wind, and newly added product, all-weather sea surface temperature, based on the comparison with ground truth data, and also a comparison with AMSA 2. So please visit my poster. Thank you.
Okay. Hi, I'm Kazuki Nagata from JAXA University. In my poster, I talk about this topic. JAXA provide two brightening temperature product for based on the Barker-Scribble method. Level 1R for footprint matching and noise reduction, and level 1H resolution enhancement of low frequency channels. But the Barker-Scribble method can sometimes produce a strong Gibbs artifact, especially in coastal region, as shown in the left panels. And so we are developing methods to suppress coastal Gibbs artifacts and improve coastal brightening temperature reconstruction. The application results are shown in the right panel, demonstrating a clear reduction in artifact, which leads to improved geophysical retrieval, such as sea surface temperature. Thank you.
Hi everyone, my name is Mattia Sabatini. I'm from CNR of Italy and the University of Naples Partenope. I'm presenting a work, a poster about the integration of AMSR2 SST into the Copernicus Mediterranean SST products, which currently are derived using only infrared sensors. So if you're interested in the merging of these two infrared and microwave, feel free to reach out. Thank you.
My name is Toru Hirawake from National Institute of Polar Research. I'm interested in the impact of temperature increase on the phytoplankton growth. So there are several periods to calculate climatology. And so at the first point of my study, so I compare the two climatology data set between the two phases, 2002 to 2025, and another one is 2002 and 2014. That's all.
This is Ninja from Jamstack. So we compared the several data set, SST data set, and we found the marine heat waves metrics are quite different among the data set. And we can see in the left panels, they show even different distributions. And we also access the uncertainties between the data set. You can see in the observational data, quite few Southern Ocean, the large discrepancies. And also we found in the Arctic region, of course, also in Antarctica, but we here only show the Arctic region. And you see when the sea ice is present, the two data set, one is OSST and another is OSGIA foundation SST. You can see they behave quite inconsistent. So I think this is a problem, and I hope your team can improve it. Yeah, thank you.
Hello, my name is Yoshimi Kawai. I was involved in satellite SST long ago, but I'm now working for the Japanese Algo group in Jamstack. This is a case study on the marine heat wave in the Oyashio region. So I examined the response of oxygen, dissolved oxygen on the marine heat wave using BGC Algo float. And the results, both ice peak mixing and heaving of density surface were important for the response of dissolved oxygen on the marine heat wave. Thank you.
Hi, everyone. I'm Davide Cavaliere, and I'm a researcher at the National Research Council of Italy, CNR. And in this work, we focus on the marine heat waves and ocean acidification streams because they are becoming increasingly frequent and intense. However, it is difficult to separate the effects of the anthropogenic climate change from natural climate variability. And to address this question, we use sea surface temperature and surface ocean acidity data, time series in particular, single spectrum analysis combined with synchronization metrics to separate the contribution of major climate modes such ENSO, PDO, NEO, and so on from the contribution of climate trends. And we find that ocean acidification streams are primarily driven by anthropogenic climate change, while marine waves and cold spells arise from a combination of climate trend and natural climate variability. Feel free to ask questions during the poster question session if you're interested.
I'm sorry.
Thank you. Just quickly, this was a comparison between the Coral Reef Watch and the GHRSST products for heat waves off of the Hawaiian coast. And the major conclusion, I know, sorry, apologies, I know you've heard me say this so many times, resolution counts and matters. And one of the issues that you see clearly is the increase in marine heat waves in both data sets from 2016. It's dramatic. Thank you.
We investigate the characteristic of marine heat waves and marine cold spells in the Western North Pacific from 2018 to 2025. We used GHRSST data, which is a product by JMA, and followed to HOB data in 2016 to define events based on percentile thresholds. And this figure indicates the maximum duration of marine heat waves in 2024. Our main findings is the long duration of marine heat waves in 2023 and 2024, with durations exceeding 400 days, especially in the crucial extension region, which is the northward of crucial extension. In contrast, marine cold spells often occur shorter, less than 100 days. Thank you.
Hello, everyone. My name is Gianluca Volpe. This work is about the phytoplankton responses to single and compound ocean extreme events, mostly marine heat waves. It was developed within the MITO project, Multiple Threads on Ocean Health, and in collaboration with a bunch of colleagues from the Institute of Marine Science, most of which are today in this room. There are several messages that I would share with you. Come along in the poster session.
Great. Hello, everyone. I'm Wiebke Kolbe from DMI. And first of all, I would like to thank EUMETSAT and Copernicus for their travel grant. So I'm actually, it's actually possible to stand here in person, so please come and talk to me. And the poster I brought with me is about the aforementioned ASTI in some of the presentations today, and it's an Arctic and Antarctic combined IST and SST climate data record. So, and yeah, specifically the process about our new version of the data set that will be released later this year. So if you have any interest, questions, wishes, or needs for such a data set, then please see me at the poster. Thank you.
Hi, I'm Ligan Schmidt. I'm from JAXA ELC. So I'd like to talk about the GHRSST satellite. So the left side is the GHRSST overview, and the middle one is the SGR sensor characteristics. So SGLI can observe the from the ultraviolet light to the thermal infrared within the quarter kilometer, the higher resolution. So the SGR can capture the detailed CIS cloud and of course the SST. So let's discuss about the SGR usage within the capability and the performance. Thank you.
Hello, everybody. So Steinar Istud. I'm here to present a poster about in-situ observations of sea ice surface temperatures in the Marshall Ice Zone on behalf of colleagues who did the main part of this work, where we placed so-called open met buoy simple radiometer on the ice. As you can see in the middle picture here, a small, very smaller radiometer, cheap one, but calibrated so that we could try to do proper skin ice surface temperature measurements in a simple and cheap way. And we present some comparison of these in situ observations with VIRS and MODIS dataset of ISD. So if you're interested in ISD validation, please come and see our poster. I have 2 posters. Yes, and the second poster, which is more my work, it's about nighttime discrimination of open water and sea ice. So how to actually at nighttime be able to identify sea ice and separate sea ice from water in the martial ice zone. On your left side, you see a classical daytime image with very high contrast between the bluish ice and the black water as a false color image. And on the right-hand side, you see the temperature, brightness temperature difference between the 8.5 and 12 micron channels at the same time, because it's available also at daytime. And you can see the same features, more noisy, but still possibility to discriminate ice and water at nighttime. So the poster is about this, and if we can use this during the whole long polar nights. Yeah, it looks promising, work in progress. Come and see our poster.
So hi, I'm Gary Wick, no graphic, no formal poster. The work that I'm doing is something of a hobby, as I've had to assume more administrative duties. But the basic idea of the work is based on the high latitude work. There's a lot of interest in some of these biases at high latitude. Our lab was involved in field projects like the Mosaic campaign, where we have a large number of very detailed atmospheric profile observations in Arctic conditions. And so there's an opportunity to compare those with reanalyses data, some of the other products. And so my pitch is we have the opportunity for these validations. If you have interests in sculpting what that might look like, please talk to me, and happy to kind of customize this work as I can. So thank you.
I am not Victor Primitson, but I'm here to show his poster. Victor works mostly on the geostationary AXPO algorithm, and as Shaquila mentioned, the development version 3.10 is in in our science development area. And so Victor did some comparisons of the improvements. And he also made a nice chart to, if you're interested in all the data and where they are and what versions they are, you can consult that. And I will be happy to answer questions. And if I can't answer something, I will be happy to refer you to Victor. And by the way, I'm working really hard to get the scientists here next year, if I can do that. So you'll be able to talk to Victor or Oli or so on in person. But thank you for now.
Hello everyone, my name is Yasushi Takatsuki from JMA, Meteorological Agency. We have developed a new global hydrogen SST that integrates the existing JMA two SST products. And we will operate routinely from early 2027 to use for the operational use. And this SST analysis neutral was slightly improved. Thank you very much.
My name is Norisa Usui from Meteorological Research Institute of JMA. In this study, we developed a new data assimilation scheme to improve SST forecast and analysis. In the developed assimilation method is based on a weak constraint for debug and aims to enhance short-term and small-scale SST variability. We apply this scheme to a North Pacific model with a 10-kilometer resolution and conducted data assimilation experiment using Himawari SST. And in the poster, we present a detailed assimilation method and result of data assimilation experiment. If you are interested, please visit my poster. Thank you.
Hi, my name's Owen Embry from the University of Reading, and I lead the ESA Climate Change Initiative for Sea Surface Temperature. A few years ago, we released the version 3 of our climate data record, which now covers 1980 to about 3 weeks ago, with ongoing updates funded currently by Copernicus. So if you're going to use any version of our data set, I do recommend the latest version because it's greatly improved compared to version 2, and version 3 will be used by ESMWF in error 6. In my poster, though, I'll be talking about our plans for the version 4 data set. So come and hear about what's going to happen in the next couple of years. Thank you.
Last year, I presented an evaluation of the contribution of SLSTR to CMC analysis, but it was from the operational data collection free. So this year, I will present the work we did to assimilate SLSTR collection 4. So comparison with collection free, and also how what is the contribution of this data in both version of CMC-SST. So please come and see my poster. Thank you.
Oh, this one. Okay, so somehow this one was not in the list, so check out number 23. So it was prepared by Emmanuel Autret, and it's about the Callista project I mentioned this morning, so which aims at preparing future missions for ultra-high resolution SST, so like Trishna, STM, or Eagle, by providing users with similar high resolution data products from existing missions, so Landsat 9 and EcoStress. So we prepared the processing toolbox in Python so that people can also process data over their own areas, but also demonstration data sets and online services to access and display the data. So we hope that with this preliminary data set, first, we tackle the challenges of producing a resolution SST, but also we foster the tech of this kind of the new data by users and applications.
So thank you for all the poster presentation. So before just in beginning the poster session, I would request the help of Jorge. Jorge, come with me, and we will do the establish. This is the. I mean, you've seen in the agenda the symbolic handover of the Greek science lead. So we will proceed now. Anne cannot be here, so it will be Jorge doing that. So I will ask Jorge to join me. And then we will welcome our new science lead to come to the stage. And we will make the symbolic handover of the grist. Can you, would you like to say some words, Jorge?
Yes, is that okay?
Yeah.
It's such an honor, Chris, to do this, and as Christina was mentioning, couldn't be here today. And first there was Peter Manette, then there was Anne Reed, both great people, and now, and following in their footsteps, is Dr. Chris Merchant as a science lead for this amazing organization. Thank you.
Well, of course, moments like this are always a little bit awkward, but thank you very much for your words, Jorge, and thank you all for entrusting me to be the chair of the science team. I want to speak to as many of you as possible in the coming week. The next few years of GHRSST are going to be quite interesting. We have GDS3. Now, we're at GHRSST27, so a new version of a GDS does not happen very often. So techie though this is, it's a significant moment for GHRSST. Of course, we have the good news about AMSR 3 data coming out this month, which is nice to coincide with this meeting. And we're looking forward to the ultra-high resolution missions that are coming up in the next 5 years as well. And this will drive, I believe, a lot of innovation, and it will be great to be part of that. I'm very happy to hear your thoughts about the future directions of GHRSST, both scientifically and in terms of organization. So if you have views, please come and see me during the current week, and I'll be very happy to talk to you. But thank you, Jorge, for standing in for Anne, and thanks for your words.
Amazing. Thank you. It's
just shows how generous GHRSST is that they've already put my name on. So I expected to have to organize that myself, but thank you very much.
Thank you, Chris. Thank you so much. Thank you, Christina.
Okay, and now we can just start the poster session. I would like to, I don't know, do you want to say something from the, okay, go ahead.
After you.
It's fine. It's fine.
Okay, I have an important announcement. This room will be closed in 15 minutes. So please take your luggage and move out as soon as possible. Thank you.